Welcome everyone to the Keshe Plasma Reactor Group for Tuesday, November 1st, 2016 in this part of the world. I'm Rick Crammon, otherwise known as Reactor Rick. And today is going to be Plasma Man, as we have plasma balls in the background. And we're going to talk about plasma, because that's what we do in this group. Okay, enough of Halloween. That was all so yesterday. And just wanted to make sure everybody had the full effect of the Plasma Man. Someone nicknamed me Reactor Rick recently, so I can go with that. That's pretty cool. I will need my glasses back from the... Okay, so yeah, welcome everyone to the Keshe Plasma Reactor Group. Let me get my audio plugged in so we don't have that live stream echo. Okay, bear with me here. Okay. Looks like all systems go. Good. Just don't have my hat on. Need my hat. It's part of the outfit. Need a white one, I've been suggested. That's a good idea. Need big Keshe logo. Spaceship Institute. Yes. I got my shirt on though. KFSSI. And this is the one with without Canada, just the KFSSI on it. We replicate the same technology as the universe. It's a saying from Mr. Keshe that I really like, actually.
Is the Keshe Foundation Canada all set up and running now?
Well, it's running as about as good as someone can run with one leg. Literally, I broke my knee recently, or damaged it pretty severely, so I've been sort of ambling around a little faster every day, so that's good. But yeah, it's basically running. We just have to get the manufacturing sector going, and that's a tricky deal. What we really need to focus on now, I think, is just getting workshops happening all around the country. We've had one on the West Coast here recently, and that was really successful. But we need to be able to have basically weekend workshops every weekend in um, every major city of Canada, and lots of rural places as well. And there's people out there. It's just a matter of organizing. And I've got a friend that's contacted me recently from Toronto, for example, who wants to set up students from the university to do testing of the different Keshe products and so on, to do, lab testing and try to do some verification and support for the Keshe Foundation through the university system. So that sounds like a really good plan, and there's other people just waiting to help. It's a matter of organizing it all, and it's been difficult to get all the cats rounded up in one herd, you might say, in different places and so on. But it's slowly coming together. I got t-shirts made for the workshop. That was one big step forward. And I do have a site that I'm working on. I'm working with, we're supposed to have a meeting soon with the Keshe Foundation to work out this whole logo, t-shirt, hat thing. There's a site that I've set up that could possibly be used with, you can order all these different qualities of t-shirts and styles and different hats and all the other paraphernalia that you can get with a logo on it, and it would all be available in one place. Okay, yep, I've got some plasma balls in the back, and I've been playing with them, playing with my balls in the back here, with some of the sound pickup gear that I've shown the last couple of weeks, like my electric test tube here that's plugged into the audio of the computer, and this has turned into a pretty interesting sensor. This one with the nano-coated wire inside, and it's now sort of suspended in the middle. It's like a cup in the middle of this sphere. It's got little things sticking up in the middle of an insulated wire, and it goes through and touches this central electrode here. And it's quite interesting. The fact it's quite powerful. It's strong, and it's you can't even get too close to these plasma balls, or it overwhelms the system and so on. And
Just a thought there, Rick. What if you had a copper in the bottom half of the one ball there? Put a copper in there, copper foil as a ground plane. Would that do anything?
Yes, exactly. That's I thought of a copper coil, maybe a spiral coil, going around that bottom part, and then connecting to the ground pin, which is pretty much buried right now, but it could be brought forward. Actually, I could run foil over this whole thing and over this whole thing here, and then right onto this main pin, and that would ground that whole area. Maybe even just leave a little hole in the end, sort of where the main sensor part would be, and it might be quite directional as far as picking up the fields go, and not have the interference around it. So yeah, that's an idea. That's something to think about. It could be aluminum foil, it could be copper, it could be a copper spiral. It's different ways to look at it. Yeah. And of course we got the electric Gans ball, and that's pretty sensitive. I can hold that over, and these things, each one of these sensors picks up slightly different range, or in some cases quite an extreme different range of fields. I've got some sensors will pick up the field of the plasma ball, which exists about a meter away, and it has like a barrier that you go through that has a distinct loud noise in that barrier. And some sensors will pick that up and some won't. I've got my super sensitive radio that won't even pick up the outer barrier the way the little simple sensors will. So it's quite interesting to discover that sometimes simple is better in this world of sensors, it seems. I had an interesting time with this guy, actually, because I took the globe off, or I took the outer part off, and it's just this on the inside. And I've actually added Gans, the 3 kinds of Gans, as drops into the middle, and it's absorbed into the filaments. And then I dried it out, so it's kind of a whole different creature now. And I put that on this thing over here. I put that. How'd it go? This was plugged into this guy. This is the iRig deal that converts the. It's just basically a preamp. It adds a little bit of power going into the computer, and this simply plugs in to the port there. So now I've got a handheld sensor. That's pretty cool. And then so what I did is I just stuck it. Basically, I just set it up like that in the middle of the nano-coated coil, and it's on a nano-coated plate that's underneath the coil as well. And the other part about it, this red wire in the background here, it goes up, 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 like the Friendly Giant. Remember that show? It goes way up to, well, actually, behind this light. Light. There we go. You can see that the alligator clip goes up and connects to this spring coil here. And the coil goes up, 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 and connects to my, I think it's a 22 foot or something, might be a little more than that, 25 foot antenna piece of copper wire that's strung throughout the room here. So basically that makes this plate assembly and so on a little hypersensitive, let's say. And I had some very bizarre effects, I guess, earlier when I don't think I can do it now because it probably is not set up and so on. But, well, why not try? Let's give it a go here just for curiosity's sake, if nothing else. It may not work out. These experiments with this kind of setup, it's like every time I try it, it's different. It's really hard to get consistency with it because there's so many variables, and a little bit of moisture makes a huge difference. Like I breathed on this before I put it down last time, and it made it hypersensitive, just the moisture from my breath. Let me see here. I can maybe zero in on it a bit more. And I'm going to start the software. I think I'm going to. Let's see.
Very nice setup.
Okay, so I'm going to have to put my speakers on so that you can hear the audio through Zoom. So that might put an echo in the live stream, but it's probably a good thing you just have a little more effect. That's if it works here at all sometimes. And plus the plasma balls are on and they can kind of interfere too, but it's all good for fun. Let's see what happens. Okay, let me get this off. Let me see, I should have some effect here. Maybe I have to reset this. And try this again. Try to turn that down because it's kind of it's in overwhelm mode there. Sorry about that if it maxed out people's speakers or something. Try to get it into a range. Can you hear that on the Zoom okay?
Yep.
Okay.
That's fine.
Okay. Okay, so that's kind of the basic sound for now, I guess. It's all, like I say, it's always different, but let me see what happens here when I get close to it.
Is it possible to turn the globes, plasma globes off? to hear the voice.
That might. Let's see if what difference that makes in the sound as it's recording. Not too much difference actually. It's mostly just its own location. Like when I move an active plasma globe over, you can hear it there. Let's see if I can. Let me make the camera go back a little bit. Okay, so there's a barrier right here. See that? In other words, right here, this distance, there's like a force field or a Coulomb barrier, a thin film, a thin
Wall.
membrane is a good word for it, actually.
Yes, sir.
And it's like a membrane at a certain distance, and you can hear the plasma ball. Well, it's actually this that's going through the field, and it's right about here. So
Membrane. Yeah, P-brain.
see, now it's through the membrane. This is through the membrane. Membrane's on the other side here now. If I bring it back, same thing. See? Once it's inside, then it's quieter and it's actually less field energy until it gets really close. Oh, I just went dead. Isn't that interesting?
That's very interesting.
Completely quiet. I might have overloaded the system or something. I don't think so. I think it's negated all the field action. I've never seen it go quiet like that before. I mean, it's gone quiet, but not quiet like that. That's quite... Now I move back a little bit. Comes back, and then there's the loud one right there.
Yeah, just right there. Yeah.
And then it gets fuzzy, like kind of a... It'd be good, interesting to process that noise we hear now. It's like white noise, but if it was slowed down, looked at in a processing, audio processing thing, it would be interesting. So there's another barrier there, right? One there, one there. This one's a lesser one, but it's there. And then it goes completely dead, right up close to the coil. Even touching the coil. I'm touching the coil with the plasma globe, and it's actually arcing off onto the wire. Arcing off to the antenna. What? The antenna should make that radio now just go crazy. It's arcing onto the antenna. This thing is blocking the signal totally somehow. Till I move away a bit.
I wonder what the radius.
Do you have a technical specification of the amplifier, so which bandwidth of frequencies it supports?
Yeah, well, it's got a little bit of specs on it here. Let me turn it off briefly and get that. It's I've got a couple of different units. These aren't the most powerful one, but it's 12 volt, 500 milliamps. So that's what, 60
No, I
watts.
mean the amplifier of the audio, the microphone amplifier.
This thing here, you mean?
Yeah. Is this
It's
up
just
to
a
20
preamp.
kilohertz? More?
Pardon me? Sorry?
Is this more than 20 kilohertz? So normal audio amplifiers, I guess.
It's a normal audio, and it'll go up, like my computer will only handle up to 20,000, I think it is, and it doesn't go over that. So I have to feed a signal that's within the basic audio range in order for the computer to process the signal. But it can be beyond my audio range, and with my pitch control, my live pitch control, I have three. I'll show you briefly the setup here with the audio hijack, and you see the modules there. There's 3 pitch controls, and then there's an audio bandpass and a couple of gain modules, a reverb and an EQ. And okay, I got to.
Maybe you could visualize the spectrum you get by the microphone. This might be also from interest if there are some peaks on specific frequencies, or if this is the complete bandwidth is noisy or something like that.
Yes, I've got a spectrogram, for example. You can see, I can show that on my screen here. Just show
Hey, Rick, your white page that you're taking the reactor readings with is blocking the live stream picture. You can't see anything.
Oh, I wonder, let me see what's going on. Maybe I've got the wrong. Is it okay now? Is it working okay now?
I don't know, I've got to go back to the live stream now. Come on to Zoom.
Well, that can definitely happen. I've had some strange things happen, so it's possible that the USB kind of got a little confused, let's say, from the high voltage dose that it was taking from the plasma ball. No, it's anyway. Let me do the screen share on. Where the heck is it here? Is that it? Yeah. Just do this whole screen and then zoom in a bit with my. There we go. So I do have this spectrogram thingy here, which can start that, and that shows a certain audio thing. I think it's basically hooked up to, I think it's just hooked up the microphone right now, actually. So I have to reset the
It looks like your normal microphone and the voice is being displayed there.
yeah, I'm not sure if I can set that up properly or not, because let me see. It gets confused with so many audio inputs with
So unfortunately I have to prepare for work, so have a nice time.
Okay. Thank you for coming by.
Thank you, Rick.
So yeah, there are other, I've got an oscilloscope and so on that can be looked at live in real time, so to speak. But I wasn't going to get into this too much today unless people really want to pursue it. Yes, Libby, it does sound like a dragon roaring, you could say. It's some of the sounds that come out of this thing are quite incredible. It's hard to believe. It gets really hard to believe that this little crystal radio circuit can do so many things, and that's what I brought up in my spooky Tesla spirit radio. And I just wanted to once again, I've shown that before, but I wanted to show it on.
I was wondering, what do you have in the middle of the plasma globes? I can see something slightly blurry there, but
You mean inside the middle of these?
no, where you put three of those right in
Oh,
the middle of the
okay.
field.
Yeah. Yeah,
Like,
actually, that's
really,
a cool experiment that I was just starting to work on. Well, I've got two things. Let me go one step at a time. This is basically a replica of the original, and some parts are the original, spooky Tesla Spirit Radio. And
that's a legend.
It's a legendary. I came up with this about, I guess it's 7 years ago now, as an instructable, and won a contest and so on with it, and it went sort of viral on the internet, and gadget blogs were hosting it, and all. People are still writing me every, usually at Halloween, and I've had several comments and people putting these together themselves and so on, and for audio.
Is that a device that actually is being used to sort of wherever the Tesla is the subject, they somehow use that picture, and I've seen this on many different websites and many different subjects, the exact same pictures, and must be your creation.
Well, if it's the exact same, then it's people trying to replicate my setup, basically. Yeah. For example, if we were to, all you have to do is go into Google. Let me do screen share. Where'd it go? There we go. You do a screen share for Google and just do spooky. Actually, just spooky Tesla is enough to do it. Somebody's microphone's open there. Armin. No, somebody else. Wiki. Thank you. Let me see. Let me get this situated here. Okay, yeah, I put in spooky and Tesla, and first thing that comes up is spooky Tesla Spirit Radio, and when you click on that, you get the instructable with the radio and how to make it, and how it came about, and so on, which there's some interesting things in here. For example, a quote from Nikola Tesla from 1901 from his article Talking with the Planets. He says, "My first observations positively terrified me, as there was present in them something mysterious, not to say supernatural, and I was alone in my laboratory at night." Because he used his radio to listen to the ionosphere, the heavens, to lightning, to other stuff. He could even hear the sounds coming from Jupiter. There's a cyclic double pulse from Jupiter, and he was the first one to listen to it with his equipment. So I was basically trying to duplicate Tesla's circuit in a crystal radio as simply as possible, as Tesla's circuits were very simple and basic and so on as well. And then I have a series of videos and so on with the different effects that I've created with this radio. Everything from reading my computer screen with the radio to sensing light, sensing different kinds of lights, all kinds of experiments. Here's the parts list, here's the schematic. Again, it's very simple. You have an option of different antenna setups that are very basic. And the main item, as I mentioned before last week and other times, is that diode. That's pretty important to get some sort of decent signal out of a crystal radio normally. But I was never going for radio stations with my radio. I was always adjusting it next to a radio station or beside where you'd normally go for it. Now, people can go to this Instructable. Like I said, just put Spooky Tesla into Google, and the first thing that comes up is this Instructable. It's got click-on things where you can get the parts and so on, are all orderable. In fact, Mike's Electronic Parts made a special Spooky Tesla Spirit Radio kit that you can order from their website. And it's got all the parts to put together this little radio, other than the glass jar, that the little mason jar that the whole thing comes in, and the plastic lid that you have to make. So that's that part, and then these are the comments. I missed something there. Some of the steps. Where did that go? So there's a series of things that this can do. Here's all the steps and how to make it. I won't go through it all one at a time. It just goes through step by step how to prepare the coils, the spiral coils. And it's not exactly the same as the bifilar coil of the Tesla, but I've made those as well. This is interesting, though. I've shown this before, this Tesla football antenna. And this was, the original one is quite a bit larger than this, but it's the same sort of idea. It's got a fine wire coil, double biconical, two cones put together, fine wire inside of this heavy gauge wire. And Tesla often created his Tesla coils with the heavy wire would be the primary, and it would stimulate the fine windings of the secondary and produce the corona or some other effect. And the rumor has it, that the Tesla biconical coil was capable of anti-gravity effects. So I thought that was pretty special. And that's one of the reasons I got into that one. I didn't do anything particular with me. I put high voltage into it and other things, but I didn't pulse it the way that Tesla would have as well. And at the end of putting it all together, you can test it with an ordinary AM radio and actually get a radio station to come through with it. I was able to do that with my little spooky radio here the other day. It doesn't always do it. Depends on the ambient fields and so on that's going on. So there's all these effects. There's what I call spooky effects from the spooky Tesla Spirit Radio. You can detect lightning with it, for example. I could see a storm coming and plug this in. I can actually hear the lightning through the unit. Before you can hear it with your ears, you can actually hear it on the radio, because it moves at the speed of light as opposed to the sound of the lightning, which moves at the speed of sound, which is much slower. It takes sometimes several seconds to hear the the thunder from the lightning, but not with this unit. It's instantaneous. So he's Tesla again. He used to listen to lightning quite a bit, so much that he could tell the difference between each lightning bolt, and he would name some of his more outstanding lightning bolts after various Greek gods. I guess he was what you would call a nerd in today's lingo. Imagine sitting at home listening on your radio, because there's no radio stations to listen to. So you're listening away to the atmosphere or the universe, basically, outside of the atmosphere, because that's what he was able to do. And he could actually hear lightning up to 1,000 miles away. Spooky effect number 2, disembodied spirit voices. I've heard lots of strange voices through this radio. Some of it's probably just, most of it's probably just the effects of tuning into some nearby radio station or far away radio station that just happened to get tuned in for that moment. But sometimes there's things that happen that are just out of left field that you know is not a radio station. And it comes at a time and place where a radio station shouldn't be. So weird stuff happens, let's say. And what does Tesla say when he was listening? He says, "The sounds I am listening to every night at first appear to be human voices conversing back and forth in a language I cannot understand. I find it difficult to imagine that I'm actually hearing real voices from people not of this planet. There must be a more simple explanation that has so far eluded me." That was in 1918. And then Dale Affrey mentions in the book The Lost Journals of Nikola Tesla, says at one point Tesla chided Edison for stealing his idea and using a form of radio to contact the dead. So both Tesla and Edison were sort of in a bit of a race to try to use radio to contact the dead. They didn't know what else to do with it at that time. They really didn't have it set up for, there's nobody playing music on the radio at that time. They used it for essential communications. It was all sort of top secret, and only funky people with a bunch of strange looking equipment were able to play with it at that time and try to get someone else equally strange in some other part of the continent to communicate back to them and so on. But it's fun to think that there could be disembodied voices. Who knows? Spooky effect number 3, you can make sound with light. So I've made this little unit create sound from light, from everything from sunlight to light bulbs, laser, flashlights, and even candlelight. And it'll activate, with a laser from the other end of my house. Basically, I can shine it on the diode and get a big sound come out of it, so on. But it only responds to a change of light, not actually the light itself. So you can hold it up to sunlight and it won't make any sound until you block the light and allow the light again with your fingers or hand or whatever. So it's a change of light that activates it's basically a light sensitive diode, which you can get diodes that are particularly made light sensitive, but the one in 34 happens to be clear, so it is light sensitive. And even a candle will make this radio have an effect from a candle. Made me realize at the time that a candle flame is a plasma, and that candle flame actually gives off an electrical signal, a electromagnetic signal. And I'm thinking, especially when it's flickering, a flickering candle gives off a definite signal. And I'm thinking, what if you're in a room like some of these Tibetan monks and so on, or a church, you're in a room with literally hundreds of lit candles, and a gust goes by and they all flicker at once. And basically you're in an array that's an electromagnetic array that's putting out a pulse out into the universe, essentially, because that kind of pulse is not just a transverse wave; it's a pulsed longitudinal type wave, similar to a spark would be, and it's different than just a regular transverse Hertz wave sort of thing. So interesting. I thought with just the candlelight, I had fun with that experiment. And again, you can click on some of the videos in this Instructable, or go to my YouTube site. It has a playlist of all the spooky, there's I think 14 videos or something with different spooky effects. Spooky effect number 4, create freaky music, which you can kind of get the idea with some of the stuff I've done before with the probes and sensors and so on. You can get some quite rich effects actually with the plasma balls. They make some nice effects when you get everything dialed in properly. And here's a good one, Van Eck freaking. Van Eck freaking is the process of eavesdropping on the contents of a CRT or LCD display by detecting its electromagnetic emissions. And this can be done, this eavesdropping on a monitor, a computer monitor, or a TV, can be eavesdropped on from through walls. Basically, it could be someone next door eavesdropping on what you're looking at on your monitor by this Van Eck freaking process with some sophisticated equipment and so on. But I thought, well, geez, maybe the crystal radio circuit, it does so many things. Can it sense the colors and movements on a computer screen? And turned out, yes, it can. In fact, it did it pretty good once I get everything dialed in. And I was actually able to make a screensaver on my computer, which is normally quiet, doesn't have any sound attached to it, come through with all the, it sounds like Star Wars basically, with the flashes come through really loud and so on. And it makes it really fun to sort of look at. We could look at some of these. I don't want to get into it too much unless people really make me. It's kind of fun. It was fun at the time. This was a while ago. I just wanted to go through and let people know the different things that this simple crystal radio circuit covers. That's why I keep harping on it, because it's so versatile. It's so able to be tuned in different ways and used in different ways. Time I get done with a dozen other different methods, I thought, well, heck, maybe I can just simply talk into my crystal radio, and will it pick it up? Will it pick up the sound of my voice? I already know it picks up the full visual spectrum of light. It'll pull through a wide spectrum of electromagnetic waves, also straight magnetic waves from a moving magnetic source or a rotating magnetic source. And it also picks up on colors from the screen and so on. Will it pick up on actual audio level sound waves? This is a radio. It's supposed to pick up radio waves. Well, sure enough, I played with it long enough and yelled at it loud enough, and you could actually hear my voice being recorded faintly in the background from the vibration of the unit, basically on its little coil inside, and magnet vibrates a bit and so on because it's sort of suspended inside the jar. And it's just enough to make it work as a microphone. I couldn't believe it, but there it was. Spooky effect number 7, woodpecker in your modem. It picks up a modem, and you can sound. It makes modems sound like a woodpecker when they have their broadcast, their Wi-Fi turned on. So actually, I found that out. Now I turn off my Wi-Fi whenever I don't need it, which is most of the time. I just leave it off because it puts out a really powerful pulse. You know, tut, 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 tut. You can hear it in the radio that way. And I was wondering what this pulse was initially, and it took me a while to trace it out. And I went down underneath my table where the modem was, and that's where it traced out. I could trace it back, and similar to the plasma ball, the modem puts out a series of like Coulomb barriers, or call them membranes, a series of membranes around itself where these pulses are stronger, weaker, and so on. And they're about 10 hertz, those pulses, which are right in our alpha brainwave frequency, enough to pretty much possibly screw up our alpha brainwave frequency, which is part of the bliss and happiness and all that aspect. So it's probably not the best thing to be pulsing in the brain area. I'm just sort of blasting through here. I'm not letting anybody talk or anything, but I just wanted to quickly go through. So I said before how the screensaver came to life with that spooky effect. That's kind of a fun one to look at, but I'm just teasing with it for now. And at the end, there's some links to the Tesla articles. I especially recommend the Tesla's Colorado Springs notes. And in Colorado Springs notes from 1899 to 1900, he shows his early experiments with his radio circuits with the coil and capacitors. Basic LC circuit, which is what the crystal radio is. It's a basic LC circuit. Alrighty, well, that's about it on that part, I guess. Was there any well, there's a little thing from Michio Kaku, renowned physicist Michio Kaku explores how mind reading and routine use of force fields and other feats that are currently science fiction may become commonplace tomorrow. So there's also some stuff about the beta blocker crystal radios of E.J. Gold and so on. And yeah, so that's basically it. This thing kind of became famous. I even had a PC game named after it, the Tesla game, that the spooky Tesla Spirit Radio. Part of the game is you collect all the parts of the radio and help Mr. Fix-It Rick put the parts together for the spooky radio and so on. And yeah, it's really a fun thing. It had developed a life of its own, and it's because crystal radios are alive and well, and they basically operate under a plasma basis. I just realized I didn't have my headphones plugged in, so I'm probably not only talking a lot, but probably echoing in live stream like crazy. And I don't even have my comments up. Let's see if I can get that. Probably people are telling me something like that. Okay, well, anyway, any comments or questions or other, let's maybe get into some other stuff. What do people think there?
Just that I'm afraid, this is Tony in Australia, just afraid to start it because there goes the next 10 years. Yeah.
That's right. You got to be careful getting into that because it can become addictive playing around with that realm. But
yeah, no, I think I've got to play with that for sure.
Well, the idea is that if you keep it more in the plasma realm, and I'm trying more and more to create plasma antennas, plasmatic ways of connecting. How do we sense the Gans balls? How do we sense our coils? what are the fields around a maggrav, what are the fields around a plasma ball, what are the fields around coils, which let me get into something else I wanted to show here briefly that's associated but different. It's enough about spooky for now. Let me go full screen there and get the live stream set up better. So what I wanted to show, and I'll just zero in as close as I can get to this guy here, which is, this is a there, you should be able to see it now. It's not really happy with the autofocus. Let me just refocus. Jeez, that's not very good either. Focus. Well, it didn't seem to like to focus too much properly there, but suffice to say, this is a vacuum chamber. Okay, so it's hooked up. It's got a hose back here, and it goes back. Can't see where it hooks on there, but it goes up to the top of the vacuum turbomolecular vacuum pump, and then it has a hose that goes out of that to an auxiliary pump that's a small sort of an air conditioning type vacuum pump, and it's the pre-pump that pumps this vacuum pump, and then it has a shut-off valve here and the hose, of course, that goes through to the vacuum chamber here. And what I've got in the chamber right now is I've got a coil set up, and it's suspended in there, and I've got a similar plasma ball power supply. It was a little bigger one than these ones, and I've got a wire that goes from my plasma ball power supply that just goes to a magnet that's underneath here. Okay, so this power supply goes to the magnet. The magnet attaches to a magnet on the inside of the vacuum chamber. Okay, so you can kind of see it inside there. And so what happens is I can't show it because I've shut down the system here, and it's kind of noisy, and I have to run it for quite a long time to get the effect and so on. But I had it running earlier just to see. I just started it up for the first time in a long time to see if I could get some sort of effect. And what happens is I pump down this chamber, have a vacuum effect happen for maybe 5 or 10 minutes, and then I fire up this plasma power supply, and I start to see a glow happening, a glow discharge on the inside of the vacuum chamber, and actually starts to cover the bottom parts of the coil, maybe about a third of a third of the coil along the bottom of the smaller and bigger coils. And as the vacuum increases more, then more of the coil starts getting coated with this beautiful purple blue sort of plasma, similar to what you see in the middle of the plasma ball, but it's more sort of fuzzy, and it doesn't have all the tendrils going all over the place because it's just atmosphere air inside of here that's rarefied, and as it becomes rarefied, then it enables the gases to ionize and glow, basically. And it's a glow discharge. There's nothing spectacular about that, but I'm going to actually orientate the coil differently, mount it in the middle, and do some other tests with it. And I'm interested in what the nano coating will do in a vacuum chamber under plasma condition. I know what a regular piece of copper or aluminum or other pieces of metal will do, but nano coating's really different, so I'm excited to try it and see what I can do. Again, it's hard to see on the even if I was able to work the pump, which I hope to be able to do for next week's meeting, and but it's often hard to see the plasma with the camera. It's almost like I have to get a special ultraviolet, perhaps camera that's more sensitive on the ultraviolet range would probably be helpful for that situation. See what else. The other configuration be having a coil on the top and a coil on the bottom, and try to get a glow discharge between the two coils. The other thing is just vacuum out the chamber with the two coils in there and take some measurements. It might create an output just being in the vacuum. It's entirely possible that under vacuum condition it makes it so much easier for plasma to create itself and actually manifest. So under vacuum it might form a plasma inside the coils, for example, very, very easily. So much more has to be done in that regard. It also turns out that the MagGrav unit happens to fit, I think I mentioned this last week perhaps, but I'll just mention again that the MagGrav unit happens to fit exactly inside the tube of the plasma chamber, and it will just fit inside if the wires are kind of all neatly wrapped up and so on. As I say, it's almost a slip fit basically. It's just a slight press fit for the MagGrav tube. I'm going to put the whole MagGrav unit in the vacuum chamber and actually run it inside the vacuum and take some readings on the I've got one of these watt meter thingies, and I'll put the whole darn unit inside the vacuum chamber, and we're going to see what happens, as they say in Rick's lab sometimes, as I say anyway. Yeah, I'm looking forward to that. I hope it doesn't blow up or do something strange. I don't think it will, but I'll definitely have my safety glasses on for that one. And these are polycarbonate. It's a polycarbonate chamber, so it's virtually bulletproof actually, but on the other hand it can implode too under high vacuum. If it gets too hot, then the walls will basically collapse. It's only an 1/8 inch wall in that guy.
I should remind you, Rick, inside your MagGrav you have 3 little plastic balls which are partially filled with Gans and air, and they are going to pop.
Right, I wondered about that. Thanks for the reminder. Maybe I shouldn't do that experiment with this MagGrav. I should do it with just 3 coils set up and the MagGrav hookup and so on, without the Gans balls. Or with, it'd be okay if the Gans balls had just liquid in it. It might work.
Yeah, the Gans in there, it's thick paste, and there's just it's a ball about the size of a paintball, and it's got just a little pea-sized blob of this thick paste in the bottom of it, and then they seal the top up with it looks like a really wimpy hot glue.
Okay, right.
So it's good. They will pop, and yeah.
Right, if it had an air valve or some sort of leakage point, then that would be okay. Or if I took a pin and pin them in the top to allow the air to escape, then they would work, I suppose. But I don't want to tear into it and destroy this lovely MagGrav, so I'll have to basically I'll just make a unit and and see what happens there. I just gotta check my live stream, make sure it's live streaming. There we are. Okay, yep. And so, anyways, I thought that could be an interesting experiment, this whole thing of getting back to playing around with the vacuum again after couple of years of not doing it, basically, and getting into other realms of stuff. But there are some experiments that definitely need to be done inside a vacuum, and got the gear. It's time to get my butt in gear, I guess, and get the job done. So, any more questions on that stuff? I have a note here from Wasilos Gutas, rather. Software-defined radio, SDR. Software visualizes the input data in the form of a frequency spectrum. There are different SDR packages I tested in the past with specific SDR device to receive the radio frequencies. With one of the software packages, I visualized the microphone input since I had not configured correctly the software. Once I will be at work, I will check out how the what the software was called. I think it was an open source program. It would be good to see such a waterfall spectrum of the noise Rick recorded. Yeah, I've actually got besides the spectrogram, I've got an FFT analyzer, an oscilloscope, and an XY plotter as well. I think the spectrogram would be similar to what you're talking about. It has the frequency spectrum and so on. That's what I was showing in the window there before. So, anything else hiding in the back there that wants to be shown? Hiding in the front. Okay, well, this gets me back to square one here. Any other questions or comments, first of all, before we go on to another topic and introduce someone else to talk for a bit here?
Can I share a couple things, Rick?
Sure.
Just let me try to share my screen here.
Okay.
You see that okay?
Yeah, just a second. Let me get it set up here. Yes. Okay.
Okay. So what we're doing over in Arizona is we're trying to come up with different reactors that can spin somewhere around 10,000 RPM. What we found is that every time we try to do our experiments with these plastic acrylic balls, they break or they spin off. So what we're trying to come up with is something heavier duty. The motors that we had in the past, a lot of them don't go up to the correct speed. So what we got now is these little helicopter motors. These are going to be something that are going to be the key to opening up the plasma fields with the Gans materials. So once we get these little reactors set up, that will open up. We can set them in our star formations and open up bigger plasma fields that can be used for a lot of things. So this is one that we did with our 3D printer, but it's only partially. It's not the correct solution, but we're actually doing some other ones. And we're actually going to have some of these machined, made out of polycarbonate. I don't know if anybody else has any other suggestions in that regard, but
sorry, the live stream audio wasn't on there. We were talking about this polycarbonate being a good choice for this cup thing, and I was mentioning that now they have a 3D printing of polycarbonate. So I'm wondering if that might be a good way to go.
We have some graphene stuff that we're going to try also. I don't know how hardy it is, but we just got that in for our 3D printer, so we're going to try that also. But I think what we're going to probably end up doing is having a machine to fit on these helicopter motors.
Right.
If we do that, we'll have a solid enough base so that we can spin them and they can be centered and they won't wobble, and we can open up the fields. Because something as simple as this is a ball inside, or a reactor with another ball inside of it, is enough to open up a huge plasma fields if we get the Gans mixtures right.
Yeah, John, if you're going to machine the pieces, you don't have to go with polycarbonate. You have a number of choices. You can use a glass reinforced nylon. You can use a material called Delrin. Delrin machines very, very nicely. It's very stable. It's very strong.
How do you spell it?
Delrin. Yes, it's black usually.
DEL.
RIN.
Okay.
I think Delrin is probably about half the cost of polycarb. The only difference is it's not clear. It's an opaque black.
So is that like the ABS type of material?
Similar, but it's similar but more plasticky than ABS. ABS is like super hard, and Delrin is hard, but it's more pliable than ABS, I would say.
Yeah. It machines very, very nicely. It's really stable. You can get like thousandths of an inch tolerances, so you can have really nice fits. And when you machine the parts, whoever's going to engineer the parts, if you put your bearing race as part of the plastic itself, then the chances of it coming apart are going to be far less.
Mm-hmm.
John, let me show you something about the helicopter motors that I've discovered in my adventures. I've got one here. Let me we can get. You probably have some other things you want to show there too?
Other things, but I can stop sharing for a minute.
Yeah, just let me have it for a minute there.
Okay.
Okay. So this is a typical helicopter motor. This is what was basically. Actually, it's an airplane motor, but it's same basic thing as a helicopter motor. 3-pole plug-in jobby, right?
Yeah.
Now the difference with this one is it's got a hollow shaft.
Yeah.
So that gives the possibility of when it's rotating the sphere, then you can actually, I've had it running, and it can actually access it with a needle through here and add or subtract fluids from the needle going right into the sphere. Or the other thing you can do is run a shaft through there. I think it's, was it 2.5 millimeter or something like that. Decent little shaft. And it could even be a hollow shaft with an even thinner one inside of that. But typically you might have just in this one the whole body rotates, right? The body rotates rather than the inside. So the whole shaft and body rotates, whereas this part here mounts and the whole body rotates basically. So while this body rotates, you can have a separate shaft inside of this that's doing its own thing, spinning backwards, forwards, whatever it wants to do basically, have its own motor and so on. So just to give you a heads up, this is the only one I've found like that. It's an E-Flight. What the heck was it called again? E-Flight Park 370 is what it's called, a hollow shaft outrunner 1200 kV. So it's that means it's basically 1200 RPM for each volt. So if it was 12 volts, it'd be 14,000 RPM.
Yeah, that's pretty good.
Yeah, and it likes to run at 2 or 3,000 too, quite well. Doesn't like to get down really low speeds because they get kind of jittery and choppy with the pulse width.
It's only one way, correct?
Who is that voice from spooky netherworlds there?
No, come on.
Hi Armin, how you doing?
I'm doing
Can you say that again? I couldn't quite get it all.
I said it rotates only one way, correct?
Nope, you can reverse the rotation by just reversing any two of the leads.
Okay.
Yeah, the ones we got, Armin, go both. They have ones that go anti-clockwise and ones that go clockwise.
Oh, okay.
I think we can switch them with the leads, like Rick says.
Yeah, you can. That's what.
Yeah, you can get an actual motor controller that does it for you with a switching mechanism. So, and you know, they work pretty good. But what I found with this motor, for example, that a little bit of pulling on the leads ended up pulling it apart inside. And I took it all apart, and it ended up the very flimsy little leads that go to the actual windings of the motor. And I thought, oh, geez, that's not very good. So I resoldered them, and then I reinforced it with some goopy glue around the whole part that goes in there, so it's secure again. But I was a little disappointed, even though it's a fine little motor with good bearings and probably good longevity. But definitely the wiring has to be relieved somehow, so the pressure doesn't pull on it and tug at the innards. Just as a heads up for that motor, if anybody does decide to play with that one. Personally, I prefer the sewing machine motor. It's so much quieter, and reliable, and so on. And just
share a couple other pictures.
Yeah, please.
This is another type of configuration we did with our 3D printer. I'm not real happy with this type of configuration, but it's just an idea. This is the Gans room we have in Arizona.
Lovely, nice.
We're making a lot of Gans now. This was a car unit that we built. What we did is we submersed it in this this material. These are little mini ones. We nano-coated the various wires. We use this Flex Seal liquid rubber sealant coating and just poured it in.
Yeah, we talked about this actually, and what is the best substance to use? Some people are using epoxy, some are using fiberglass resin, and some are using the potting compound that they use in electronics that is quite watery apparently and sets up nicely and flexible.
I'm not sure how this is going to work. We're still testing it. But
have you did you try actually
cover nano-material?
We covered the nano-material.
Why?
To keep it in place, kind of like they do with the when they do the glue on all the liquid glue all over the coils.
But you know, your coils are absorbers. So what you do, you just kill it.
Just what? Say what again, Armin?
You just kill it.
Well, the thing is, what do you do with the car units because of the vibration problem? If the inner coil vibrates against the outer coil, it's going to wear the nano coating and Gans right off of it.
You have properly,
your support is properly done, you're not going to have any vibration.
Well, in a car though, you're going to get vibration if you don't basically nail it down in some way. It's always going to be vibrating with the engine vibrations and so on. I think.
But just understand the logic behind it. It's an absorber, and it's a semiconductor. So you're just closing all the holes, whatever you created in there.
Well, maybe it's just closing the holes with a different liquid. I mean, the holes are closed in a way by the air, you might say, or by the Gans and so on. It closes the nano holes in a way.
Just understand my point.
I know. I understand.
We nano-coat the material. We hang it. We're not touching it. We're just Gans coating it only. Then using it as a energy absorber. So, can you explain me the logic?
Well, what if we wrap those coils before we poured that stuff in? Would that be better?
When you wrap it, you already crush it. You just crash the traffic.
What do they, when they do these with the hot glue? It's the same type of concept. They're crushing.
What do you mean hot glue? Who says hot glue?
When they put hot glue all over the coils.
But
yeah, well, who puts the hot glue all over the coils?
I don't.
Right.
Well, I'm not saying
a lot of people do a lot of things.
I've seen a lot.
I just want to understand logic behind it.
That was just one technique that a group of people were using to secure the coils. But I mean, you can secure the outside of the coil, but it's really the gravitational coil inside vibrating that you're worried about wearing the nano-coating layer off. But that was always my concern too, that whatever you put in there is going to have an interaction. It's going to have some kind of effect depending on what kind of material. It's a matter of what kind of effect, whether it could kill it, as Armin's saying.
Yeah, we've done tests on this. We've tested it with fiberglass resin. We've tested it with hot glue. We've tested it with epoxy, and they all still function quite nicely. The first one.
Can you just explain me why, when we nano-coat, we trying not to touch it, and if you touch it, you just crush it, the layers, because they are so thin. They are in nano state.
Well, Armin, it's Lee here. My best results so far are the ones that are embedded totally in epoxy. My first ones I made were just tacked in place with hot glue, and I've tried really slathering the hot glue on, trying to get it into the coils. That didn't work. But epoxy and fiberglass resin. Now I'm putting powdered Gans. Titanium dioxide Gans in with my resin when I pour it, and then I'm getting my best results with that right now.
Yeah, we can understand. We can understand your argument, Armin, and yes, it is valid. But we need to have some way to protect these coils from getting bashed together while you're driving down the road, and it will happen. Even if your clearance between the inner and outer coils are only 1/1000th of an inch per side, it's still enough that over time it's going to beat the hell out of the nano coating where those two come in contact.
But
so what we're trying to do,
when you have it connected to the energy source, it's still going to nano coat. Still you have in your coils, you wash it, but still you have the caustic left. You cannot thoroughly wash it.
Yep.
So in time, when it heats up, or if it's damaged, it will repair it itself.
Except that's not what we found in experimentation.
If you have, can I tell you one thing? Just try not to thoroughly wash the caustic, and then assemble it. And then, put it in and then you tell me that it's not valid.
Well,
certain techniques that you have to use it.
That's a good point. It's the It's two different techniques. One is the total preventative technique to prevent any vibration, prevent any rubbing. And the other technique is to allow it to rub, but you've got a instant repair, not instant, but a self-repairing skin basically on the coils, and it will repair itself. That's like I mentioned in the teaching earlier today, that they use copper oxide, the same black nano coating, on the walls of certain nuclear reactors, because when the plasma or some high energy particles hits the walls of the reactor, it strips off some of that copper oxide, which is really a tough coating to start with, and it actually strips some of that off. But because of the nature of the copper oxide, it's self-repairing, then it tends to start repairing itself immediately. And so that weak spot is no longer a weak spot, and it's self-repaired and it's ready for more action. So, it's two schools of thought here, and the end thing is, does it work?
At least you can mix some Gans in it, dry Gans. That I will understand.
Well, that's true. It is an opportunity, like Lee was mentioning about the titanium oxide that was added. And what about other things that could be added, or
dried Gans or nano-materials?
Right, like the copper oxide black powder that you can make quite easily. That could also be added. What do we want to create? Do we want to create a perfect insulator? Do we want to create a perfect sort of not a conductor, but more like a capacitor than anything else, with all these little particles embedded in this substance? It's good to know what we expect out of it. For example, the potting compound for electronics, it goes in really thin, and it is a two-part thing like epoxy, but it's more watery, and it penetrates all the parts quite well. And it will be a good insulator. It won't be made to conduct electricity. It tends to insulate all the parts and keep them from flashing over, and keep parts in place and so on, so they don't break off from vibration and all that. So it might be a really good substance, but maybe some other things like, I don't know, epoxy or something else might conduct a bit of electricity for whatever reason. Certain compounds might, and it might, like for sure, silicone steel would not be good. It's quite acidic, and it would tend to conduct electricity and so on, and tends to create corrosion. So
yeah, the one you were talking about, the liquid ones generally referred to as encapsulant in the telecommunications industry.
Yeah.
Yeah. Just if anyone wants to try it. Yeah.
Yeah, it might be a good choice for that if you're going in that school of thought. On the other hand, a bit of caustic left over, like Armin was mentioning, maybe that's the correct way to go.
Yeah, maybe we need to do the test, make two, and have one with a bit of caustic, and vibrate it for a while. Yeah.
Well, as a baseline for the test, the one that I am aware of is a mid-80s 300D Mercedes. Started out at 27 miles to the gallon, and her last report was 60.
Wow.
That's with an encapsulated system.
Wow, that's impressive.
Yeah, what we need is more results.
Like this is an old 5-cylinder Mercedes.
Yeah.
We need more tests, and that brings me.
What technique you were using to test your
well,
results?
that's exactly what brings us to the next topic, which is how do you test a maggrav? How do you test a maggrav like this? How do you test the ones we put together, and so on? Which
what we do, Rick, is we use these little field detectors, the little beep 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 beep, and just feel the fields that are around the unit. You can see for example, if you put two of them together or something, you'll get a bigger field with one of them by itself, or one on top of the other. So you can actually sense the feel, the strength of the feels.
Yeah, somewhat. I'm not sure if the actual plasma fields are the same as those electromagnetic fields that are generated from those
I think
units.
they are. You know, when we did it with larger sizes, we could actually follow the shape of the field.
Right. Mm-hmm.
Detectors.
Yeah, well, there's always an electromagnetic field around any conductor that's conducting current. So, and that's basically what those things measure. But I don't know if a plasma is always measurable that way.
What
Well, we
about
can
your car?
test
What
that.
about your car magravs where you have no AC current going to it?
I was just going to mention that. We can test that fairly easily. Lee, you've got a unit there that's just pounding out plasma. You know that from the how fast it nano-coated the wires.
That's
Yeah,
exactly the
wires-
topic I wanted to bring up. So
I
maybe
got to
we
share my
can.
results here shortly.
Okay.
So if we connect those wires together, get that plasma loop going, does the detector still pick it up?
That's
I
a
haven't
good
tried
question too. That's a good question too. But I'm quite interested in Lee's technique for nano coating. So maybe we could review that again. That would be good. John, do you have more things you want to present too,
I'll
or?
just go through a couple other little quick ones real quick.
Okay.
Just to show everybody what's going on. Here's some more Gans pictures. We got our whole Gans operation all set up. That's Steve in the background helping us. The whole room is filled with Gans.
Wow, that's great.
So John, what's your secret to producing Gans fast?
Well, for us, it's not so much about fast.
Okay.
It's about low temperature or low voltage and get it correct. You know, it's more about having the correct Gans than a fast Gans. You can see down here on the bottom, we're doing the hemoglobin. We've got quite a bit of hemoglobin being built up. It's just a process. We don't rush it. We just let it go, slow but steady. That's our secret.
So you're putting about a volt on each cell, kind of thing.
It depends on which kind. You know, for example, CO2, very little voltage. CuO, a little bit more voltage. CH3, kind of in the middle. If we do like a zinc Gans, for example, we've got to turn up the voltage. Or some of the heavier metals, we turn up the voltage. Lead, we turn up the voltage. So that's really all I got. I just wanted to share some of the stuff. Okay, go ahead. You can.
Lovely setup. Nice. Thanks for showing that, John. It's inspiring. I'm setting up my back bedroom to do some Gans production. It was good to see that.
Yeah, definitely. I always like Richard's setup with all the tubes on his wall coming down. It looks really good. Yeah.
So yeah, Lee, you're gonna show some stuff, and I wanted to just briefly show this speaker wire here that's seems to be good, and this is I believe it was 12 gauge. Let me just double check that. Yeah, 12 gauge speaker wire. What are you using, Lee? Can you tell us about your technique for judging the maggrav power, which is quite a thing actually?
Yeah, there's we can my magravs. I got this is 16 gauge wire coils, and it's got that's got the epoxy in there with what's that one? Half a teaspoon per 500 ounce or 5 ounces of epoxy of titanium dioxide dried Gans, and that seems to be working pretty good for me. Wire wise, I'm using 14 gauge electrical wire, 19 strand. which I get at the electrical wholesaler. I'm going red and black wire. It's the standard color coding for DC wiring in North America here. So that's
you're wiring your red wire to the gravitational, correct?
Red wire goes to the magnetic coil output.
Okay, we've been told that that's backwards. I've got some people testing it right now, but I'm inclined to listen to Mr. Keshe and have the gravitational on the positive, okay, which most people would see that as the red wire. So rather than try to hook the red to the black and the black to the red and keep it all straight, I'm thinking just do the wiring inside the unit so that they just put red on positive, black on negative, and it's right.
That was my intent.
Okay.
So well, say that again.
You've got a number of units, and it looks like there's some that are in process. So if you could make one way and win the other, you could test them and find out which one works better.
Okay, because I haven't been getting very good results on my car, so maybe I'm wired them backwards.
Okay.
So you're saying the magnetic, the gravitational coil should be the red wire going to the positive terminal.
That's the latest information I was given. I saw it the other way around when I was deconstructing the system in my head. I saw it the other way around, but I've been known to be wrong before, so I'm happy to be as long as it works.
Yeah, well, it looks like
I kind of went with the grav to positive. And the other thing John brought up with me the other day online is the distance. Is the distance between your coils? Have you got that? You know, have you got that distance?
I've sort of minimized the distance to about a 1/4 inch. So these caps are cut down to 1 3/16 inches high instead of the 1.5 inches that they come in from the store.
Yeah, you're gonna want some space in there. What I'm suggesting for people is to start with the diameter of your gravitational coil, same as the MagGrav units.
Okay, are you talking distance between coils or distance between that little center flat coil?
Yeah, distance between the sides. Just the flat coil. What was mentioned? Try putting the unused wire into your Gans ball, into your center Gans ball, rather than just on top of it.
Okay, and that distance I assume is like center to center of the coils.
Pretty much, yeah. I mean, we're going to have to play and optimize it, but as a starting point, it's suggested we look at the diameter of the gravitational coil as our side distances.
Yeah, okay, that's what I've been working off now. Yeah, cool.
Okay, well that's approximately what I've got in there is
okay,
the coil width, the diameter between the two coils. So.
Okay. I mean, I'm not saying that you're doing it wrong. I'm just saying this is the latest information that I was given.
Yeah, well, there's lots of different things to test here. That's for sure.
Oh yes.
Okay. What I've been doing is to for field strength on these is as soon as I put these things together, I connect the two wires together, and then I test how fast the wires nanocoat. Like that's one that I put together 4 days ago, and they're already black on each side of the center connection. So this is my best unit yet. It's getting 4 feet per day on nanocoating the wires. And the original ones I had, I thought 1.7 feet per day was good, and I was looking for that sort of 1 to 2 range. But now today I just stripped the wires on these. I found two of these were black, and the other 4, they were turning black already. So now I'm up to 4 feet per day is my best rated nanocoating wires. So I'm pretty happy with those last units. Those last units are epoxy coated, and like I was just showing you, that one that's haven't had together yet. I can show you my spreadsheet here and.
Other microphone. Could you show us how you hook up the wires again to your units, and how much a 12-foot piece, or how long a piece now?
what I'm using is a 6-foot lead on each side, a 6-foot black, 6-foot red.
Okay.
So the total is 12 units, and then they just connect the the 2 wires together in the middle and then when I want to test whether it's black yet, I just strip away a bit of this black insulation sort of every day to see when it's turned black.
Okay, so basically you just short out the 2 wires, and the other ends are hooked to the black and red of the maggrav unit.
That's right. So where'd it go?
Just wanted to see that.
Yeah.
Again.
So.
Right. Yeah, that's hooked in.
Okay, and then the connection, I'm painting it with some caustic, and it's got some sugar in it, caustic sugar solution. All my joints.
Okay.
Okay.
Yeah.
And
is that pigtail on that one? How long is that? Does that go out it only goes out a short ways, doesn't it, or is it the full 6 feet?
That's the full 6 feet.
I see. Okay.
These ones are these ones are going to go into a car. They're going into a car to get tested. So
you do coat. I just wanted to establish that you do coat one end with the caustic and sugar solution to sort of start it, you might say.
Well, wherever I have a joint with some bare copper, I paint on some caustic and sugar solution.
Okay, good. That's clear now. I see how that starts.
So these, like a week ago, I was making these tests. These were just for test purposes, and I just had a short 2-foot of wire on them. But the short 2-foot of wire that nano-coats so fast, you can't really tell how good they are. So right now I've got a 12-foot piece of wire attached to the 2-foot leads, and almost immediately, right close to the connection, it turned black. But out in the middle, it hasn't turned yet, and I'm thinking these two extra connections here are slowing it down, because these are only about 2 feet out right now. I sort of strip a little insulation off to see how far it's got.
Maybe you need some sort of different plasmatic connection there to allow it to flow a little easier.
I was thinking, how do I get it black? And, like it goes black inside the wire, so I figured, well, why don't I put some hot glue around it, and maybe that'll make it turn black, but that didn't work.
Right, or maybe shrink wrap could work as well.
Yeah, so I'm
do you know how NASA connects wires?
No, how do they connect wires?
They use the traditional Western Union. And they've got a full sort of manual on how to do the Western Union, which is basically you twist around one wire with the other wire and twist around the other wire with the one wire.
That's exactly what I'm doing.
Right.
Western Union place. And I'm trying to get like on the nano-coated wire on top of the copper, there's 9 turns. I've only got 3 turns on the copper around the nano-coat, but
If I may say a word.
Yes.
Please.
Sandro here. If you put glue on wire and you expect to get nano-coated, so let's think about what's that nano-coating made of. It's mainly made of copper 2 oxide. So the nano-coating works by energizing, by heat, by plasma, or by other methods, or by chemicals, or by current, the copper wire. Some atoms will get loosened, and they will recombine with the oxygen from the air and form that copper oxide structure. So now if you seal it that no oxygen can penetrate, and the glue doesn't contain oxygen, it's a carbon and hydrogen compound, how you expect to get copper oxide?
I expect the same way as inside the insulated wire. I got a 12-foot long wire, and how's this nano-coat in the middle?
That's not so tight. Still there is a little gap.
Yes, but there's always a bit of gap between the circular wire, the strands of the wires. How many? 17 strands? Is that what you?
17.
17 strand wire.
19 strand wire, I think.
19 strand wire or whatever. It's going to have. It's going to.
They are not vacuum sealed, and some air is inside during the production.
Right,
It's
and
very little, but it's enough.
the vapors will move along the wire though, and probably inside the plastic, hot
Anyway,
glue as well, perhaps.
yeah.
Yeah.
When
We
I leave
shall
it wide
see.
open to the air, it doesn't turn black. It just stays copper color. So
That's what I was going to say.
that's-
Like I know where Lee's going with this because what's exposed outside doesn't turn black. You got to strip back to see the nano coating. Yeah.
yeah.
Another small technical detail about some kind of speaker wires, speaker cables. So recently, I got call from one knowledge seekers from a seeker from Hungary, who tried to nano coat by caustic some speaker wires, and he found out that they are not, at least his wire, it's not made of copper. It's made of aluminum, and it's coated with a very thin layer of copper. And his wire got molten, got melted, let me say in America.
Yeah, I've come across that too. You need to strip it back with a knife and make sure it's solid copper. Yeah.
Yeah, because there is new technology. They're using less copper, making the wires of aluminum and copper on the top. I don't say it's not possible to nano coat that, but probably the caustic method is not the best.
Good point, Shandor. Thank you.
Yeah. So we don't have to believe what we think about a material. We have to really know what it is made of.
Okay, so Lee, you've got your spreadsheet here.
Yeah, these, I just wanted to go through it quickly just to show some of the experiments I'm doing. The first ones here, I just had hot glue, and the first three were just hot glue just to hold them in place inside the caps, and the caps weren't cut down or anything. I didn't get very good results on my truck with this one, although it nano coated fairly quick at 1.7. I'm not sure, right? In a third tank of gas, I hooked it directly to it started out connected to the frame, and then I hooked it directly to the battery for this last tank of gas, and it's didn't give me much improvement. So this one may have shorted out because it's just hot glue on there. It's not that much hot glue. My niece, Tammy, after about 7 days, when I put it in her car, it still hadn't shown the nano coated out 12 feet, but we put it in anyway, and she saved $66 going back to Manitoba. That's about a 1,300-kilometer trip. So then I was getting a couple here that weren't producing any plasma. Some of these in red weren't doing very good, so I was getting discouraged there for a while. And then I started this other set here, and I'm getting some pretty good results on all of these guys. So I'm changing the way I nano coat my coils too. The wire I'm using seems to have a little bit of oil on it, and I'm thinking maybe the inner coil, the gravitational coil, isn't getting nano coated properly because I've been assembling them and then nano coating them. So right now I'm going to nano coat the coils first, then I'm going to assemble it, then I'm going to do it nano coated again the second time to make sure it's all good. So maybe that's some problem with some of the ones up here is that my nano coating isn't very good in the inside coil, and I can't see it to see if there's a problem, because I have been getting some that are nano coating, and I have to put them through the second time through the process.
One thing that you could try too is to dip them in the vinegar and salt solution for a while first. It makes them super shiny. It actually etches into the surface of the copper somewhat, and will actually start dissolving it after a while. The salt added to vinegar, I thought, well, what's the deal with salt and vinegar? Well, salt is NaCl, and the vinegar has how does it work? It's got
Acetic
not
acid.
So what is it again?
It's an organic acid.
CHO and so on, and it ends up that the addition of salt with the chlorine actually converts the hydrogen to HCl, you get hydrochloric acid by adding salt to vinegar, just momentarily, but it's enough to etch into the copper and actually give a good sort of almost porous structure to start the nano coating with. I think that's one way that the coating will happen. I noticed the coating happens a lot faster once you started with a super clean surface without any fingerprints and other stuff on it like that.
So cleaning the copper before the nano coating, it's very important.
Right.
Okay.
There are oils which we say that the caustic soda will terminate with the oil, it will make soap. Yes, but there are some artificial oils made of silicone which resist to the caustic.
Right.
So that's why a first wash in detergent and some etching like Rick recommended may not harm.
Okay.
Another thing, an observation from another knowledge seeker from Romania, he said that he made some coils and he failed to nano coat them for several weeks. And when he tried to nano coat them, he observed that the nano coating was not uniform, and he suggests it's possible because of it got some patina or some oxidization while standing too much in the air.
Absolutely.
So to seal his wire coils, if he buys bare wire, or if he takes off the insulation, he uses it immediately. He's not letting it too much in the air.
That's right.
For days and weeks.
Copper will start to oxidize immediately after it's exposed to air. It looks shiny for a long time, but it's actually forming mono layers of atomic layers, just rapidly building up.
I suggest another kind of cleaning, which was put in my attention by Armen about 1 year ago, if I remember well. He has shown some kind of perfect nano coating, and he used electrochemical etching. Let me wipe this one. Actually, he used salt solution, but I had very good success with caustic solution. I combined the information from Armen with information which I seen in a factory. They were etching electrochemically some metal. So it's a way you put your plate which you want to clean between two other plates in a container. You fill it with caustic soda and water. I used specifically potassium hydroxide 20%. But whatever you use, sodium hydroxide or potassium hydroxide, about 20% is quite enough, not need for more. And then the trick is to connect it to a power source. So you connect, the external plates, you connect to positive, and the plate which you want to clean, that you connect it to the negative of a DC current source. So that which will have the positive, maybe I shall draw it just in cross section symbolically. So from here, the current will flow, such ions will flow in this direction. So atoms will be removed from the top, from the surface. So here is important to keep equidistant counterplates, so to have the same distance. Otherwise, if you have here the plate which you want to clean and you have not uniformly the other, in that case you will have a higher current here and a smaller current here. And it will eat off too much of the bottom of the plate than from the top. I think this can be used also for coils with the same method. You put here your coils, your coil set, and you put near just 2 plates. They can be of copper, they can be of stainless steel, they can be of graphite, whatever. Doesn't matter really. Minus always to that which you want to etch. And this all in a conductive liquid of caustic. Keep the voltage below 2 volts. If you have a higher voltage, it will produce, it will discompose the water, it will produce a lot of hydrogen, it will produce a lot of oxygen, and you can risk to create an explosive concentration of hydrogen, which can be dangerous. So that's why I always keep low voltage. We had another knowledge seeker in Romania, Teomantea, who had got this idea, and he used this method for producing the nano copper, which he needs for capacitors, or for putting in the soup, which he puts on the coils and the maggrav units. So he put in a vessel 25% sodium hydroxide solution, and he used 2 plates of copper or 2 wires of copper. He connected them to plus and minus. So then he observed that he obtained a kind of black nano coating on the positive after a while. So he reversed the voltage. He changed the voltage, and he obtained the reverse action. So once in a direction, once in the other direction. And then he has got a lot of copper which was falling off, such a nano copper. So that can be maybe also useful information.
Yeah, thank you for that. That's great information.
And sorry for interrupting your nice presentation.
Well, that's good.
I have to maybe to leave the computer.
That was good information. So this week, what I'm testing is I'm filling the center gap in those car magravs with epoxy. I got 3 units set up filled. I'm going to test that, see whether how that works, and then I'm going to make some different ones with different size coils to see if you can make them smaller, still get the same plasma fields coming off, and I guess the ones I'm putting together right now, I'm testing I'm reducing the amount of powdered Gans I'm putting in the epoxy just to see where the limits are on that, because I've had it from ½ teaspoon to 2 teaspoons for 5 ounces right now. I'm just testing one with 1/4 and one with 1/8 of a teaspoon just to see if they work, because the ½ teaspoon seems to work just fine. So I just wondered how low I can go on that. So that's what's going to happen here shortly. So, and hopefully I'll get some in some cars here in this coming week on the batch that's I've got that are looking good right now. So, any questions?
Well, one of the strange things that we're noticing with a bunch of people doing this is that people are making them identically, and one will work, one won't work. The only thing I can think of is, like you were saying earlier, is that your center gravitational coil isn't getting nano-coated properly. And that's because the assembly, the construction is identical between the 2 systems, and one works and one doesn't work. So there's a couple of fussy little details in here that we're just not seeing quite yet, or not confident with yet. I'm hoping that, because you're doing such a high volume, maybe we can fall into that somehow.
Well,
Yeah.
one thing that came up last week was when the coils were cut open, you could tell that the hot glue wasn't getting into the inner coil, so that would be way. Some units, maybe even the epoxy isn't getting into the inner coils, and maybe it's shorting out from just rubbing inside. I'm wondering.
Yeah.
I could show those pictures again if.
Yeah, that'd be great.
Okay, so that's the one with just hot glue. And as you can see, I couldn't get it into the coils to hold the things together. I could actually pull that coil right out from the inside. So hot glue is not the way to go as far as I'm concerned. That's another hot glue picture. I forget whether this is epoxy or resin, but you can see the epoxy and resin got right into the in between the magnetic and gravitational coils. And these coils here were 144 turns for the outside, and then the 81 on the inside. So they were tight inside this 3-inch cap. They weren't stretched at all, so there was very little gap between the wires. I've changed that. I'm making less turns now and stretching them a bit, so there's a little more room to get the epoxy in. And this is the resin or whatever, and it's the same thing. You can see it's getting in there between the wires. So there's no concern about the epoxy and the fiberglass resin being too thick. It runs in between those coils real good, and on my stretched out coils, I'm sure I'll get it right into the center, no problem. So it'll be nice and solid.
Yeah, and we've noticed with Dave's experiments with his health pens down in Peru, he encapsulates them into fiberglass, and they work just as good as anybody else's. So I'm pretty confident that the fiberglass, the polyester resin, really has virtually no effect on the plasma itself.
Yeah.
I wonder if putting them in a vacuum condition briefly to pull the bubbles out would be a good idea too. Or is it a feature, not a bug, to have that voidness in the very center of the coils there, where it doesn't quite get to? It's kind of a place for the plasma to flow, perhaps. You know.
I'm thinking this. I'm not going to have that void now that I've stretched my coils and made them a few less turns. So.
Yeah. Trying to figure out if it's a feature or a bug. It's hard to tell.
Yeah, I've kind of thought about that too. You know,
you might have destroyed the best reactor of the whole bunch, Lee, with the one with the hollow core in the middle. And you let out all the good gases when you cut it open, because it had the right gas mixture from the resin hardening and so on. There's probably leftover hydrogen gases in there that's just right for the core of the reactor. I don't know. Interesting. You did mention, wasn't this a filled Gans ball?
Yeah, this was filled up. There was the composite Gans with it was a fairly liquid paste. Let's put it that way. It was a thin paste. It filled up, and right now I got a little bit of thick paste on the bottom, so the liquid disappeared out of that ball for some reason, and that was a fairly skookum plastic ball, I thought. So, and this is only a couple of weeks or a week old, so it disappeared pretty quick. So, not sure why.
Interesting.
Maybe that was a good thing. Yeah.
Maybe. I mean, I guess they were saying the factories only put a little dab of big dab of paste. So.
Mm-hmm.
So anyway. So that's that.
Cool. Thank you.
I did have, I got just getting a new batch of balls for the center going, and I've been buying these beer pong balls, miniature beer pong balls from Amazon. They're
Miniature
look
beer
like
pong.
they're
These
3/4 inch diameter.
These are so
And they
pygmies
look
can
like
play beer pong.
feel like HD PE plastic, the Type 2 plastic. So
Yeah.
they're pretty good.
Huh.
The question I had though is, up to now I've been nano coating these plastic balls inside and out, and just the question: is that the way to go? Is everybody else nano coating their balls for their magraves, their plastic balls?
I think Mr. Keshe said it wasn't necessary at one point.
We're not doing it.
Well, would
And-
not the nano coating want to encapsulate the plasma? And we want that plasma to radiate.
But does it encapsulate it and let it build up, and then eventually it radiates anyway? It has a bigger field. That's what I'm wondering.
There's different ways to look at it for sure. In a way, the plastic's already nano-coated. It'll tend to repel water quite easily and so on, as if some plastics already have a specialized surface that it's sort of nano-coated. The inside of ping pong balls, sometimes they have special inert gases put in them. For example, it could be a perfect environment to spin a ping pong ball just as is without anything added. Just the gases in there might be the right combination to start with. Anyway, yeah, interesting.
So there's no answer on that one.
Yeah, we're not nano.
We're not the variable.
We're not putting ours in any type of solution beforehand. We're just using them like they are.
Okay.
I think when you get into like the reactors, you might look at whether or not you want to nano coat those.
Yeah, I think it depends on exactly what kind of reactor and what kind of stuff you have inside and so on. For example, if you have some kind of plasma that's a ionized gas happening inside there, and maybe it's a little hotter than a ping pong ball can handle, then you wouldn't want your gases touching the walls of the reactor at all, let's say, or you might have a perforation instantly. But if it's working with liquids, then it's there's still powerful liquids in terms of acids or bases or combinations of those. It's possible to create that ionic environment that's the same as in those early reactors that Keshe worked with the gases and so on. And the walls of the reactor are less important in terms of the nano coating with the liquid, I think. It's more a case of if you have something that tends to ball up the liquid easily and repel it, maybe that is more effective than the nano coating process in that case. It's a different kind of plasma. Don't know, any ideas on that? What is the perfect inner coating for a sphere that's rotating with Gans in it, let's say, or with...
Our thinking is that we just put it as much of it into a plasmatic state as possible right from the start, so everything operates in the plasma state rather than having the matter state involved in it. However, those little plastic balls, we typically don't put any nano coating on beforehand. Not that they can't have it, but we don't.
Are you working at all with strong acids or bases inside the balls?
Yes, of course.
Okay.
That's the key to getting the reactors to open up. That's my understanding.
Right. Yeah, tricky situation, especially with those acrylic balls that love to explode at any moment. Well, that's where we need if anyone finds a good source of clear polycarbonate balls in various sizes that are easily adaptable, that would be a good link to have. It's difficult to find them in polycarbonate. They do make certain sizes, especially larger ones. You can get giant spheres quite easily. They're kind of expensive, $100 and $200 or more. But what do you got there, Lee? You're going to show something?
Oh, I was just going to say I had an acrylic ball here. I was going to spin it one time, and it's been sitting around. Yeah, but the acrylic goes.
Well, we lost the critical moment there. The acrylic, and I lost your transmission.
Soft with whatever. The acrylic ball disintegrated, and where the hole is for the center shaft is just leaking right over there. So the acrylic balls aren't the greatest.
Yeah, they'll start cracking just sitting. They're made for Christmas and they disintegrate slightly after Christmas.
Yeah. So.
Yeah. There is a new kind of material I see that's come out recently that they're making glasses out of a type of plastic that's super strong. It's very close to polycarbonate, but it's sort of half between polycarbonate and acrylic. They used to make acrylic glasses, but they would break too often. But now they have a new thing. It's called, what was it called? 5-letter name, like Viron, I think it's called. Anyway, I saw those in the local superstore, so that you'll see that kind of material start to come out and be more available. I think it's available for 3D printing now too. It's quite strong. And what do we have here? A field detector being unveiled.
I've been putting these plastic frames around my car mag wraps, or that's what my intent was, for a couple of reasons. You know, a few months ago, Mr. Keshe was saying that was one of his secrets to put plastic chips in the pipe frame and fill it with CH3 Gans after he nano-coated it inside, and it would increase the fields around the unit. So I say I got this. This one doesn't have any CH3 in it. It's just got the plastic chips in. It hasn't been nano-coated inside yet, and it, I don't know, it showed a bit of white around it, and this one has the CH3 in it. It's been nano-coated and it shows the same white around it. So inconclusive, this ice test.
What are you talking about plastic chips?
Say again?
What are you talking about plastic chips?
Well, Mr. Keshe was saying he used to get Coke bottle caps and chew them up into chips. What I'm using is I take a 5-gallon bucket. I mount it to the faceplate of my lathe, and I take my block plane, turn on the lathe, and I have these fine shavings come off the 5-gallon bucket. So I'm using the type 2 plastic, the HD heavy duty polyethylene plastic, and I just stuff it in the pipes, and then I fill the pipes with caustic to do a nano coat, and then I drain that off, and then I put CH3 in, CH3 Gans water. So, but most of these test mag gravs right now, they're running without the frames on them. So I'm going to once I got this test done to see how fast the nanocoats wire, then I'm going to put the frame on them and see if it speeds it up at all, having it inside the frame. But the second reason for this frame is it makes it really easy to fasten these things under the hood of the car, because you can just get tie wraps or whatever around these pipes and tie it in. The little, today I put the other unit in my truck and without the frame on it, and it's hard to tie in there to get it really solid. So there's that's the other reason for putting these frames on around them, is to tie them in. So, and there's the one with I don't know, it doesn't show up very well. There's the one with the pipe frame on it, came out of my truck, but
nice.
They're easy to fasten in when you put the frame on. So, but right now that ice test didn't work for for expecting the two different patterns in the ice, but I got the same pattern. So I'll test it with my wire method in the future here.
When you
see how fast the wires nano-coat with the frame around it.
When you did the freezing test, the ice test, did you totally freeze it right up close to the plastic, like the whole thing was frozen, or was there a water gap in there?
No, it was solid. This is showing. This has been melted.
Right,
so,
I see. Okay.
Oops. Like that's the bucket. That.
Oh yeah.
Okay, so it was just sort of white around the unit, but that's the other unit that's got white around it too. So
yeah.
It's
one thing I'd really love to see with the ice experiments is the control. One without, like without Gans coils in it, to compare to one with, so you've got a control. You can see the difference.
And the water itself is critical, because if there's oxygen in the water, it'll create bubbles that start to come out. Or if it's for example, if it's boiled water, then you've boiled out most of the bubbles, and it ends up could set more clear, and it would show the true fields more clearly, let's say.
Yeah, maybe I should be using distilled water instead of my tap water here. Like
possibly,
this one here is the one without the Gans water in it, and I've got more of these little streams of I guess they're little bubbles coming off, or whatever they are, off this one than I do the other one. So I would have expected it to be the other way around. But so anyway, I'm saying that test was inconclusive.
Right on. Well, thank you for showing anyway, because it's a good accomplishment to freeze these things. I'm still thinking there might be a means of freezing the maggrav units in like low temperatures and have them turn into superconductor mode just from the low temperatures. It already has the right configuration and gap and so on. It could be that freezing and or vacuum condition is enough to really turn on these babies to get them to do what they're meant to do in life.
I can see a nitrogen tank being wheeled into your place anytime soon, Rick.
Yeah, not a bad idea, actually. Not a bad idea. Dip the whole thing in liquid nitrogen and throw it in the vacuum chamber. Vacuum it down at the same time, perhaps.
You get 10 times more people watching.
Yeah, I'm sure things could. There's lots of room for things to go wrong there. People like to watch that. Okay. Anything else there, Lee? That was really good.
No, I think that's it for me. I'll let someone else have a chance here.
Okay. Any other questions or comments at this point, or somebody else want to show something?
No, just Lee's doing great work. Like it's really great to see what you're doing each week, and it helps us all. Thank you.
You're welcome.
Hello, everyone. Good morning, Rick.
Hello.
Yeah, this is Paul.
Oh, hi, Paul. How are you doing?
Fine, and you?
Good.
Okay, just say that we have make two magrovs connected one to each other, and we get now 96.5% reduction.
Really?
Yeah.
Wow, that's pretty incredible. So, would you be able to show any of that, or do you have any videos or something, a link you could show us?
Yeah, I put it in the Keshe Foundation Togo Facebook. Maybe tomorrow we can show it on public teaching.
Okay, I'll make a note of that.
Okay.
Is that one you sent into the blueprint teaching or not? For the testimonial?
Yeah, yeah,
Okay.
yeah.
Okay, I'll pick it up there then. I published those for you.
Okay. So before I make one magrove and we was getting 15, 16, and then now we combine these two and we get, when we start, we get 80% reduction and more it's going up. And now we are at 96.5% reduction. We are near to 100%. It remaining now 3.5% to get 100% reduction.
What kind of loads are you putting on to get those results? Are you like putting it through its paces and putting a heavy load on to do that, or just a light load?
Yeah, we put a lot of things. We put the 3 Gans base, and I have one gun specially I make with caustic, which is blue Gans. So I take these blue Gans and I spray on our coil. And I spray also on the capacitor. And we get this reduction. I can give it for you. I have these Gans here. I can show you. Yeah, I have this. I can show you the way.
You want to show a video or what, or a screen share? What would you like to do?
Yeah, I want to put just camera and show you.
Okay, let me get you lined up here. Just a second.
You can see these Gans.
Just a second. You can now. Yes.
Yeah, so these blue Gans I have put, and we get these results.
Right. Okay.
What's it made of?
I take a nano copper wire. I take soda, crystal of salt, and then I take a distilled water, and I put I don't know what is the name. The name in French is tool sheet, I think, and I put it in face of nano copper plates, nano copper wire, and I get these Gans. And at the down of these Gans, we don't get any Gans apart of.
Hello? Don't get any Gans. What was the last thing you said? Don't get any Gans. We seem to have temporarily lost the connection, or is it just me? Maybe it is just me.
No, we all lost it.
Oh, okay. Yeah. I was feeling a little lonely there for a minute. Okay, well, let me see if he's still on the list. Oh, something dropped. And we back up.
Can you see it on his Facebook page?
Do you have it open there?
I'm asking, can you see it on his Facebook page?
Apparently. I'll have to check it. Maria, you have to mute you. Or maybe it's Shandor there. There we go. I'm still trying to get my thing to come up here. Facebook. See if he's come back or not. Doesn't look like he's back yet. Well, it's probably not such a good connection from Togo. Yeah, it's a closed group, so I don't think the video's gonna be. It's not a good idea to play the video from the closed group. It's not gonna be happy. We have a microphone open. Tony, did you want to say something, or did you know your microphone's open?
It was closed on my.
No, the other Tony. There's another Tony, yeah. Here, I'll mute you if you don't mind. There we go. Okay. Well, Paul seems to have disappeared, so we'll have to just fill in for Paul. Back to me. All right, well, what else do we have on show and tell and lined up here? I don't want to go to the, if it's the same one, Keshe Family Togo / Keshe Foundation Togo. It's a closed group, and only members can see the posts, and that means if I show it on live stream and so on, it's probably not a good idea. But if you can send me the video, then I can show it. Or if you can share it directly from his screen. Okay, let's move along to our next topic, which is I'm listening.
Stand for Standing Rock.
Stand for Standing Rock? Is that what you said?
Yeah, it was. Just been following it in the news. It's really interesting.
It is. Basically, all the Aboriginal tribes are binding together and opposing this pipeline thing, both in Canada, U.S., and virtually all around the world. So this is a new development, and it's going to change. It's a game changer. And there's people that are, it's not just the Aboriginals. There's people, of course, of all stripes that fully support them. And rightfully so. This whole oil business, it's time for it to come to a close, and those that are continuing to attempt to propagate it, well, they're on the wrong end of history in this one. So
yeah, they made a really big mistake opposing unarmed people with militarized police. You know, in the day of the internet, it's gone worldwide.
And they arrested them on the same day that they acquitted I think it was the Bundys that were the white folks that took over a piece of land and were armed and so on, and they acquitted them on the same day. They arrested a couple of hundred of the natives for unarmed opposition.
Yeah.
So that was a big mistake, unless they did that deliberately just to try to get more publicity for this issue, which, you know, there are parts of the government that are fully supporting the Aboriginals. There's other parts that are against, and so on. It's a confusing thing, because the ironies and the hypocrisies are starting to rear their ugly heads as more and more people are more and more informed about the connections between the the pipeline companies, the oil companies, the banks, and so on, all the big business that are supporting this multi-B with a billion dollar proposals and projects, and they don't have the approval of the majority of people, and they certainly don't have the approval of the portion of our society that's susceptible to the results of what happens when we burn fuels, essentially. People like me get nauseous, get sick, can't have an ordinary life, can't go out in public because I get totally wiped out from diesel exhaust and other exhaust fumes and various solvents and so on and so forth. And that's because of my overexposure over the years from the various trades that I've taken on and so on. But it's I'm just like a canary in the coal mine. Everybody gets it, and their whole system is designed that way, and it's not a good karmically way to live. We shouldn't be. I was looking today, I got this double-decker school bus ahead of me on the highway, and its exhaust, instead of going up way up the top where it should be, it comes directly out into the vents of the car that's behind it, like myself, or the car was ahead of me in this case, and me, because it comes at ground level right into the vents of the car. And if you don't shut your vents, and even if you do, it still gets in through creaks, cracks, and crevices and so on. So it can make someone that's chemically and environmentally sensitive, like myself, go into virtually instant nausea and ready to do drastic things because it makes me crazy. It's just really annoying. And humans shouldn't be doing that to each other at this day and age. Why would we be poisoning the person behind us, who poisons the person behind them, poisons the person behind them, all the way up the line, and all these kids in the cars and so on. And of course the school buses are all diesel with these kids in them and so on. And now they've just finally discovered, the researchers have discovered the carbon nanotubes that come from diesel exhaust are found lodged in the lungs of kids with asthma. And now they're making finally a direct link between the exhaust fumes from diesel exhaust and children with asthma and other diseases will be tagged as well, because these same carbon nanotubes now, they can tell what engine they came out of, tag them what organ they have eliminated or caused a tumor in a human, and suddenly your tumor will be tagged back to particular engines and particulates that come from a particular batch of fuel or a particular batch of vehicles that have created that. And when that happens, which will be very shortly, you're going to see all the healthcare costs tagged right back to where they came from, which is the oil industry. And primarily, there's other folks and things involved and so on, including various smoke in the environment and so on. But still, it's a big part of it is the pollution from vehicles, and they've known this for some time. But now they have the scientific proof that insurance companies are interested in to tag where the initial cause came from. And that is going to revolutionize everything. And it's the same with oil tankers, where they can tag back now if there's an oil leak, they know exactly which tanker it came out of and so on, because of each batch of oil is slightly different, has a different sort of DNA signature or some kind of signature like that. And they have the equipment to figure it out. I just read today they have a new invention coming out that will track the DNA from fish species that go up a river. Just by putting this thing in the river, the sensor in the river, they don't have to count all the fish anymore. They can tell what fish and how many have gone by or have been in that river from their water sample, from the DNA, trace DNA in the water sample.
That's amazing. Yeah.
It is amazing. And of course, there's trace DNA everywhere in virtually every sample of water everywhere. Imagine what the seawater, where all these tributaries from the rivers are dumping into the ocean, with all that DNA dumping into the ocean DNA. Where I am, they take the polluted water and just dump it into the ocean, basically, without proper processing and so on. So all that DNA gets every single teaspoon of seawater must have just trillions of parts of DNA. So there's probably a little bit of us in every drop of seawater. Think about it. Pretty profound, eh? Oh, well, we've all dumped into the ocean one way or another. I am pretty much sure of that. But, well, some people inland may not have. But still, the DNA travels in strange ways, just from the cells falling off our body can get picked up by the wind, deposited in other places, and so on and so forth. So it's a pretty wild way to look at it.
Another avenue of we're all connected.
That's right, and it gets right down to the plasma level in terms of the nano particles, nanotechnology, nano world, where things are way different. And when you get down to the atomic level, then things are actually all interconnected, as has been discussed sometimes recently. For example, all the hydrogen atoms, you look at the universe, which has hydrogen atoms apparently through the entire universe. They don't think there's a square meter anywhere, a cubic meter anywhere that doesn't have at least one or two or a few hydrogen atoms in the places in space that have the greatest vacuum and the least amount of particles. There's always a few hydrogen atoms. And as Mr. Keshe said, in the vacuum of space, the fields of a atom will open up. They'll expand to fill up to a cubic meter of space for one hydrogen atom. So if that's true, then all hydrogen atoms through all of space are interconnected just from that field level. If you push one here, then it feels it, the next one feels that movement. They all feel each other's fields right through the entire universe, and probably instantly, since they're all interconnected. And also Nazrin Haramein has discussed recently what's inside the proton. The hydrogen atom is basically all these Planck distance level fields. And so what you get inside of each proton, which we think of as just a proton, it's the most basic thing, or maybe there's a few funny little subparticles that make up the proton, a few other subparticles. No, he's saying that it's like an entire universe inside each proton, inside each hydrogen atom. The proton is essentially, it's like if you were to go inside the proton, it would be like looking out into all the entire universe, all these solar systems and galaxies and universes that are. Yeah. That's the kind of space that the Planck level.
Yeah, fractals, just repeating. No matter how close you look, it up.
And in that sense, each individual proton, or in the case of space, it becomes an ionized atom of the hydrogen, so it'll be a proton and an electron somewhere else. So that proton is individualized, so that each proton has its unique signature. From when you look inside and see all these tiny, tiny Planck level fields going on, and it'll have a different signature than the hydrogen atom beside it, let alone the one on the other end of the universe. So each one is individualized, yet each one is linked together through its prime or principal energy. Its principal matter, its principal, it's all the same inside, basically. So it's this enigma.
Yeah, I mean, that's how I see, you know, Mr. Keshe talks about positioning, you know, and I always keep that in mind, that everything is in relation to everything else. You know, everything has it's put in its place by what it is, how it's put together, you know.
Mm-hmm.
And we have interconnection across everything. It's just a matter of tapping.
Some connections go across the entire universe, basically, all at once. So, I mean, a ripple happens over here, it's felt over there, and the other end, basically, with these hydrogens. So, even though we might not feel it physically because we're so dense as humans when it comes right down to, compared to the finer hydrogens, which, you know, what's the first thing that hydrogen does when it lands on planet Earth? Zip! It's gone. It's out of here. You know, gravity doesn't hold helium well. That's why we put it in balloons to. It works even better than helium for a balloon, but helium is tends to blow up less, so we tend to use it more for balloons for kids' parties, especially where candles are involved. They probably learned really fast that hydrogen balloons were not good.
Yeah.
Hydrogen balloons and birthday candles are a bad combination. You can see the safety sheet on that one. Never use hydrogen balloons in a birthday candle environment. Anyway, it's interesting in the sense that in a plasmatic way, the plasmatic fields, the magnetic gravitational fields are all interconnected, and I think that's the main point. And they're connected in a way that's it's not like a wave that slowly sort of moves. They all move together because they have to through positive positioning. And I think there's a lot to that, actually. It comes right down to it.
The Standing Rock thing, you know, began. I mean, they've been there fighting it for quite a while, and you know, it was a Native American thing. Then it became a native indigenous thing, and now it's become worldwide. People have just responded to it because it strikes a chord in them that, you know, that it's just wrong. You know, they've been using lots of really dirty tricks. You know, they've
been there peacefully since April. Like, you know, I was counting on April, May, June, July, August, September, October. You know, it's like that's over half a year camped out, just trying to stake your ground on your sacred land, and not allow this desecration of planet Earth from all these pipelines running all over.
Yeah, and apparently they avoided an environmental impact statement by breaking up the pipeline into tiny little sections. So it was looked at a little section at a time, whereas if it had been looked at, which is the legal way to look at it, as an overall thing running, you know, 1,500 Ks or however long it runs, well, then they would do an environmental impact study. But they know if they did that, it would open up a whole can of worms.
Yeah, I bet you 10-1. Well, I wouldn't bet that much, but bet you 10-1, as they say, that the railroads did the exact same technique when they put the railroads in. We're only going this much further. It's just this area, and we want to make sure that we buy up this land and separate and do this sort of thing, and you guys live on the bad side of the tracks, and we'll all live on the good side of the tracks and keep on making tracks all the way down. And a lot of people got displaced and were upset and expropriated and all that kind of thing from the railway going through, and they learned techniques to, hence the term, being railroaded. Which, means you are pressured. You're pressured into letting go of your estate or whatever thing in life, and other things.
They've had their own oil workers planted within the crowd, and as they've been coming up to police lines, the Indians have been passive, and these people have been pushing people into the police lines, and they've been arresting those people. There was a guy who was one of the oil workers who was with a rifle, pointing his rifle around, firing off rounds to sort of incite or give a reason for the police to open up. They've used rubber bullets. They've used high sound wave techniques. We wouldn't even to use that kind of force against your own people is just
here's the exact thing. That's right. And I watched the news tonight, and what amazed me is they had back-to-back news. They had the Standing Rock thing, and they showed these military vehicles, like a lot of them, full out military, heavy-duty armored vehicles. They've got 7 or 8 militaries there now. And they've got dogs, they've got all this stuff. Now, here's the thing. Here's my point. I'm watching that and I'm going, wow, that's really heavy duty. And then I see, bing, the next news article is Mosul. They're eradicating ISIS in Mosul. Exact same shots. It looks like it's the same desert shots, and it's flat, and they've got the military vehicles, and they're all moving in. I just went, wow, I can't tell the difference here. I can't tell the difference between America and Mosul. And they're using the same equipment, the same exact Humvees, the same fatigues, the same military outfits, the same guns. And I'm just going, wow, this is incredible.
Yeah, and I mean, they had a they approached the Hillary Clinton office, and the Hillary Clinton office wouldn't even take their letter to talk about the issue, and Obama has been avoiding it like the plague. They were hoping it was going to go away, and he had a speech today basically backing Hillary Clinton for the election, and he was hammered by so many people asking questions in the blogs about it. Well, maybe that was part of it, but he made a statement saying that it's sort of like the army engineers are in control of the pipeline, which is a really strange situation in building it. And they're looking, and Obama said, we're looking at alternative ways to reroute around the site, and we'll let it go for 3 weeks. He's hoping in 3 weeks it'll go away, No. But he would be he would be getting pressure from the oil lobby for saying what he said. But he had to say something. And you could see he spoke in a very quiet voice. He was measuring every word,
Yeah, well, it's very big in the U.S. now. They're now finally the first point in the history of the U.S. They're a net exporter of oil. They're no longer reliant on the Saudis or anybody else. They're a net exporter due to their shale oil works and so on. So they're in a different position, and that's why some people are interested in continuing with the oil for, well, it's virtually forever, because you can keep
apparently they have a contract with the Chinese for this oil. A lot of it will be exported.
Yeah, they can actually start exporting.
The Chinese, yeah.
A lot of it you wouldn't want to burn in your vehicle because it's too hard, like the so-called tar sands in Canada. It's called dirty oil, not because of the extra CO2 it takes to process it, but because of the high sulfur. And sulfur's like the old lead was in the gas back in the 60s, killing people and making them dumb.
Byproducts, processing it, yeah.
Yeah, and it's expensive to process the sulfur out of it, and it's really bad to burn. They get caught putting high sulfur in the fuels in the last few years, and it took 5 years through the courts for them to reveal what their ratios of sulfurs were and so on. And finally, Shell Oil, gave over the documents and whatnot.
Yeah.
But it's just a shame the way the whole deal's run, and this is the greatest travesty, of the 20th century and now the 21st century, and it's for humans. We're not doing good. We got some interference here, Tony, I think, or is it Samuel Gordon?
The webmaster for the Cannonball Camp, where they're all staying, was talking about that she signed 1,000 people into the website yesterday. And when she was,
they're doing.
And honestly, they're checking who people are before they just accept them, as I assume they do with the Keshe Foundation. They vet them.
They're doing a Facebook thing that's called check-in, where you can check in at the site, and it looks like you're actually at the site when you do that check-in feature of Facebook, apparently. So they're asking people to check in there, and well, the thing is, the authorities are checking in too, and they're watching people. They know everybody who's at that site, and now they'll know everyone who's also checking in at the Facebook site and so on. So it's a great big check-in fest, but people still have to take a stand and basically take a chance, take a stand, and and go with what you need to take a stand for, basically. And
well, I think a lot of people are responding because of the time that it is, because of the connectivity with the internet, that people are responding in a way that they never envisaged when they started this. They're getting, if they're getting support, and I mean, they need people there on the ground, and financial help, all the other kinds of help. But give you support. I think it's important, and it's about. I mean, fossil fuels is over. It's a time to move on, and this is a good starting point.
Even the car manufacturers recognize it now. They all are looking at electric vehicles replacing after Volkswagen's big fiasco in the last year or two here with, they've been doing it for a decade or two actually, with their polluting engines, diesel engines, being 500% and actually is up to 500 times more, which is 50,000% more pollution coming through than they're supposed to, and so on and so forth. And now they have multi-billion-dollar lawsuits, and that's just the start of it. They haven't even started the health lawsuits yet.
I mean, when you add up the true costs of it, it doesn't make sense.
No, it's all over now for the diesel manufacturers. They see the writing on the wall, and they're pulling out of supporting their own diesels, and they're moving toward electric and other types of. You see, fuel cell is becoming very popular now. Hydrogen and so on. All these different things are suddenly popping out, but even the car shows are showing electric cars are coming on strong. You got the Tesla car now, the quickest car in the world, quickest production car. It's electric, and people love that 0 to 60
and out with running on hydrogen. The only byproduct was water.
Yeah, but it never is, because you never have pure hydrogen. You never have a completely clean fuel cell technology. They always start with methane. It's got all kinds of bad stuff in it, and what happens to all the byproducts, and where do they go, and the catalysts get messed up, and so on and so forth. So they say, yeah, ideally it's water at the tailpipe, and that's like saying that ideally the internal combustion engine puts out CO2 and water, according to the formulas that I was given in high school and university. You add the hydrocarbons, and it all burns perfectly to give you, CO2 and water, which are both fine as far as trees love CO2 and water's good for us. But when you add in all the other stuff that ends up, the nitrogen, for example, in the atmosphere gets burned in the internal combustion engine, ends up with nitrous oxides and nitrogen dioxides and all this stuff that ends up being very toxic, and so on and so forth. There's 200 or more different chemicals and so on in car exhaust, and diesel exhaust is even worse because of the high pressures and temperatures. Ends up making carbon nanotubes, which are the wrong shape and size for our lungs, and for when it goes directly into our bloodstream, then it ends up in other organs inside of our body and lodges in there, and that's how tumors get started. So, now they're predicting, our lovely government's now predicting a 100% cancer rate in the next 2 decades. 100%. How they can do that, how they can get all those little people out in the woods that are hiding, trying not to get cancer and so on. 100% cancer rate, that's what's predicted according to the way the charts go right now. So, that's what we get to look forward to, that's what we get to pass on to our kids. This is not okay. No, we won't be having actually, I'm actually in favor of pipelines. I think pipelines are a great idea. The problem is the product that's being transported in the pipelines is incorrect. They should be transporting clean water. And they should be transporting the clean water to the friggin' natives that have the shitty water up north, especially in almost every native reserve has poor water quality. Yeah. And that is outrageous. It's making them sick and stupid and everything else.
They use in the pipes is substandard. It's porous.
Yes, they're being poisoned by everything, by mercury that's, in their food supply and so on, from the hydroelectric dams that flood the area. Every time they flood the native area with the hydro dams, I've discovered recently, it puts out methyl mercury. Methyl mercury is 10 times more poisonous than mercury. Gets in the food supply of the fish downriver of the dam. Because everywhere that's dammed, it rots the vegetation underneath that's full of this methyl mercury. It gets into the water of the dam. They offload some of the water, and it gets into the total fish food supply. And the ones the natives rely on especially. It's not acceptable. So that's, one of the main reasons I got involved with this Keshe technology. Mr. Keshe said it's time for mankind to stop the burning. Period. And I thought, wow, how do we do that? And we're still working on it, but boy, we're getting closer and closer.
Is all about that. Is about people taking a stand, no matter where you are, because we're all one. If it's not, if it's not you, it's someone else. It's going to be you next week, and it's just enough. Enough is enough.
Yes, the burning of fuels, even the UN admits, and it's a conservative estimate, 4.5 million people a year die from the burning of fuels every year. Think about it. In a decade, that's 45 million people. That's just from the burning of fuels. And think about the people sick from that. It's at least 100 times that number over the planet. I mean, it's just ridiculous. If it was a some kind of disease or if it was AIDS killing that many people, or if it was any other disease, even if it was the flu, we would have every health agency would be instantly on it, and it would be all over the news, and we'd find some solution, because it would be utterly devastating to lose 4.5 million people a year. That's over 10,000. Think about it. Well over 10,000 people every single day. What natural disasters have you heard of recently that's killed 10,000 people in one day? Earthquakes? No. Plane crashes? No. Wars? No. Nothing. Yet, burning of fuels kills 10,000 people every friggin' day. It makes hundreds and hundreds of thousands and millions actually sick every single day.
Yeah. And
if it was, think about it. That's more people. More people. Let me rant one more thing. One more fact. That's more people every year than in the Holocaust. I hate to bring up that word because I'll get some sort of lawsuit or something for saying it probably. But no, think about it. Was there more than 5 million people per year in the Holocaust? I don't think there was. I think it was close to that number.
Some have reduced that figure down quite significantly, but that's a very political issue. Yeah.
Yeah. But the idea is there is a comparison. We're living in a Holocaust every single year, and have for the last 50 to 80 years since these infernal combustion engines were developed. And, look at the word diesel. Die, sell. Selling death. Die, sell. Just look at the word. D-I-E, die, S-E-L, sell. Diesel. That should be a clue. Gas, getting gassed, gas chambers, gas. Blah. Yeah. Humans, we're just slow. We're just, a little behind the times. Anyway, that's one of my pet peeves of everything. It literally makes me sick, and every day when I drive into town, every single day I get nauseous from the environment. It's outrageous. And they used to have air care in this area where they, test your tailpipes, and they did away with that 10 years or so and decided that people like me are basically disposable people. They even calculate. They calculate how many people will die every year. They know that in Ontario, 600 people will die from air pollution every year. That's, a couple every day. Bing, bang, bing, bang, bing, bang. They know that. And they know that across Canada, 6,000 people will die from air pollution overall. And they know in the U.S., 60,000 people will die. And they know in all these other areas, and it adds up to 4.5 million altogether, especially in the developing worlds, where we dump our oil, our Canadian oil, where they're trying to ship our high sulfur, extremely polluting, extremely toxic oil to other places like China. But fortunately, China got smart recently, and they have laws against high sulfur oil burned in. They don't allow it in their cities now because they know it's tied to all the health effects. And here we are still trying to pawn our high sulfur oil the same way we tried to pawn our asbestos on the planet. And now they're trying to clean up all the asbestos that we pawned upon all these places, and they're still selling the asbestos to these third world countries.
Yeah.
Okay, well, that's why we need to keep working. Sorry, go on. Go ahead.
It just goes on and on. Yeah.
It does, and it's a shame, but that's part of the human factor, and that's part of what we're here for, is to make changes, and we are. We're making huge changes. Look at how different the world is now due to the Keshe technology especially, but nanotechnology in general and other technologies that have started to take root. But just look at the Keshe technology and the way it's taken off, and on a grassroots level, and all the workshops going on all over the world and spreading just like wildfire, and people loving it, and grandmothers taking it up, and kids taking it up, and scientists and laborers, or it doesn't matter what you do or how you think. If you're willing to give it a try, you'll find some use for this technology for you, for health, for healing, for the power, for making materials, and all these different things. And it'll become more and more so as we go along. And there's just, in all of that, there's no room for making fuels for cars, better with this technology. It's just like, I heard somebody was doing that. I just went, what? So that we could keep burning fuels? Are you crazy? No, this is not what the plasma technology is for. It's not like, it's not made to be, like, some people have this idea, they want to use nuclear technology to melt the tar sands. So you have this nuclear device in the tar sands, melting it, so that you can produce the liquid in order to ship it through these pipelines, because you have to melt it in order to get it liquefied enough and keep it melted all the way along, and put on these liquefiers and all this stuff. You have to use natural gas in order to dilute it, nice pure natural gas in order to dilute this yucky bitumen stuff. So they want to use relatively clean nuclear fuel to make diesel fuel from this bitumen and ship it through these pipelines. I'm just going, I just lock up when I encounter that kind of thinking. It's just outrageous. And even now it's outrageous what they do to get this oil out of the ground with the fracking and so on. Anyway, I just on my little rant there, I didn't mean to get too wrapped up in all that, but it is important, and this whole Standing Rock thing has brought it to a head, essentially. And you'll see the same thing popping up now in Canada in different ways, and everywhere the pipelines are going in, you're going to see this kind of resistance, and eventually they're going to have to pay attention, because a lot of people are getting behind it, and a lot of people have just had it. We just had it.
Line. If you hold them up every day, you hold them up, it's affecting their bottom line. You're making it less attractive to them.
Yeah, I think that's what happens a lot of times. The politicians they'll say they're in favor of pipelines and so on, but then they'll take so long to drag the process through the the process of approval, that basically the pipeline companies can't afford to keep going, because it's taken so long to get the approval process going. So I don't know. We'll see.
Sorry, Rick, I didn't want to get you wound up on all that, but
Oh, I love getting wound up on it, because if it wasn't for that resistance, then I wouldn't be here. If it wasn't for the oil companies, then I wouldn't have gotten behind all of this Keshe stuff. And basically, they created a monster in me, and it's time to fight back. And boy, we fought back pretty damn hard, and there's a lot going on in a lot of different areas. Look at the peace, the way the peace councils and so on that Mr. Keshe set up, the Keshe Foundation set up, and the peaceful way that this technology is being transferred. And you can't beat it. You just can't. It's all of the resistance and all of the stuff that's been going on. That's the last gasp of the prehistoric monsters that are out there. It's over. It's over and out, basically, and we're just picking up the pieces now, and they're trying to figure out where they can reinvest their money and so on and so forth. But I highly advise them to invest in pipelines, but make sure it's for water, not for that nasty oil now. And maybe if you give nice clean water to the Aboriginals where they need it, way up north especially, and lots of other places down south, you name it, virtually every reserve needs clean water. And if they can do that, then that's a way that these oil companies can help pay back for this rather dirty, tawdry history that they have when it comes right down to it. And they've created a lot of changes in the DNA of mankind just through this. It's a product that's, if you actually use it, then it causes toxic damage. Hello, you can't use the product without causing damage to the environment, to people, to everything that it comes in contact with. I mean, it's such a ridiculous product. How could you have a product in this day and age that causes so much havoc and have so many people completely blind to it, and not only blind, but unable to use their nose and their body to sense danger in that environment. But anyway, I think it's a great topic.
That they drew police from like 6 or 7 different states around North Dakota. And what's happening now is that cities within those other states, like Oklahoma, are writing letters saying to draw back to their capitals, basically saying, pull back our police. We need them for other things. That this is not what we support. You know, like cities.
Yes, yeah.
Letters from Seattle, from all around the country, saying, you know, like, pull these guys back.
Yeah, I'm surprised they were able to drum up enough police that actually don't have enough conscience that they can go there and provide their duties and whatnot. You know, it's becoming harder and harder because, you know, police are often giving up against the resistance of protesters. Some cases I've seen the police basically have put down their shields, put down their weapons, and just congregate with the protesters because they agree with their cause. You know,
well, that's been happening here. There are police who've been apparently just handing in their badges, you know, saying they can't do this.
Yeah. So it's an interesting process. It's great actually. I'm so pleased to be living in this time period. I never expected that they'd actually nail Volkswagen with these horrible little cars that pollute so bad. And in the area I'm in, as soon as I see that Volkswagen emblem, I either back off or try to go around, or somehow, how can I get this out of my face? Because I know it's going to be a stinky vehicle. I know I'm going to get sick from it. And it's just like so repeatable and so ridiculous. And they've known this for so long. And they did the same. They did something in California a few years ago. They dumped a bunch of Volkswagen Rabbits on the market, several 100,000 of them, when they had this alternate engine that polluted less, that they could have installed in these Mexican-built Rabbits. Instead, they dumped all those engines on the U.S. market, got it in just before the December 31st deadline, right, or made it legally before that, and then they had all these older, sort of one-year-old Volkswagens to dump onto the market from the dealerships, cheaper than the brand new ones with the less polluting engine. And that was one of the sleaziest moves I've ever seen in a company. And God knows how many thousands of kids have been affected with asthma from that, and how many hundreds of people that have been totally made sick, and how many have been killed and so on because of that boneheaded, greedy, totally greedy, it's all based on greed, move. And then you hear there's, you know, a couple of families basically are running this Volkswagen company from their closed offices where they don't allow outsiders and so on. Well, hello, all that's going to be open right up like a can of worms right now because your whole company's disintegrating before your eyes. And now you're going to have to pay back. and have to find a way to pay back so that you can accommodate this really bad karma that's been earned over this period or over this time. So what now Volkswagen, of course, is doing, they've had for quite some time now, they're working a little extra hard on their electric car. And they'll probably come up with something like the Volkswagen Beetle that will be the ultimate electric car and be really super cheap and super easy to use and whatnot, like they should have had 40 or 50 years ago at the turn of the Second World War. Instead of getting heavily invested and heavily involved in all this petrochemical oil business and raiding other countries and all of this war business and so on, which, yes, it generates lots of bucks, and yes, there's lots of money to be made in healthcare and you know, caring over sick people and you know, putting bullets in people and all that kind of stuff and firing off rockets, and all of that is, you know, big business, lots of money to be made. But hey, there's more to life than making money. You got to figure that out, and controlling others and making money is really not where it's at in karmically.
Yeah.
So I think they're starting to figure that out. They painted themselves into a corner, as they say. They've
well, people just don't believe them anymore, you know, and that's the difference. Is that 20 years ago, 30 years ago, people wouldn't believe the government could be doing some of the stuff they're doing. Couldn't believe they could be corrupt. Couldn't believe.
I couldn't convince anyone that
get mileage out of the car. That's what you'd expect to get.
Yep.
You know, they give you figures. You know, you trust those figures.
Yep.
Wouldn't even
same exact thing. Think about it, the same exact thing happened with the truck manufacturers. They also cheated on their emissions exams. And so they got away with it for many years, and they just exaggerated their emissions. But in the testing, they have it set up a certain way. But in the real world, it's a different situation. You have different factors involved that ends up using a lot more fuel, and it gets on the heavy, black smoke aspects of the motors kick in and so on. And again, it's the same thing. The greed kicks in where they have to meet these emissions tests, and at the same time, they're the ones doing the testing, not the government. Hello? The government allows them to do their own testing as long as you show us the results. Jesus. How dumb can you get? What kind of system is that?
You hand over the responsibility for anything, it's on trust, you know, and if you don't check it, if there aren't checks and balances, real checks and balances, well, then you're going to get screwed in the end, you know?
Yep, the same thing with, you look at, I'm just going on about this a little bit more before we end things here, but you look at the new vehicles in, say, Canada. Over half of the new vehicles now are in the truck category. So over half the new vehicles sold are trucks. That's kind of odd, wouldn't you think? Well, it turns out the reason that half the vehicles sold are trucks is because SUVs are put in the truck category. And why are they put in the truck category? Because they can then cheat on their emissions, and they don't have to have the same strict emissions as cars. They can have the sloppy emissions of trucks. Well, that totally sucks. And then they make that into a whole subcategory and subcategories of that, and it's all truck. So now I go up the street, I see truck, car, truck. I'm going like, I'm sucking all the exhaust even from these new vehicles, but they're trucks, not cars. They have the emissions of trucks, not cars. And often now you get dual exhausts in these things, and they stink. I can smell the exhaust from these new, BMWs and so on with these, 400 horsepower turbo engines and whatnot. Well, they stink because they also cheat on their emissions. They have a set for the dynamometer testing and their closed tests, And then the real world, let her loose. Doesn't matter who's sniffing, whose nose is in behind, because that has been our philosophy as humans and as car manufacturers, is stick that tailpipe right directly in the, you know, in the atmospheric vent of the person behind you.
Yeah.
Before we go, I'll reveal my solution to all of the air pollution problem. Within 30 days, I can totally clean up all air pollution if we were to abide by my air pollution product that would eliminate all air pollution within 30 days. I bet you're interested, right? Right? Simple modification to every vehicle will eliminate all air pollution within 30 days. What I would do is I would bore a hole in part of the exhaust pipe, and I'd run a tube from that hole up into the driving compartment of the vehicle. Okay. And I would have that as a mandatory tube, this tube from the exhaust, running a smaller tube from the exhaust, not the full tube, running into the interior of the vehicle. And I guarantee you, within 30 days, it will eliminate totally all air pollution.
I think you'd solve a lot of problems that way.
You're damn right it would. See how many people would put up with their own air pollution in their vehicle.
Yeah.
And if they did, they would die. And that would serve them right, I suppose. It would also include me right now, because I wouldn't be able to tolerate it. Without an electric, I got a RAV4, but they have electric ones, but I can't afford one, so I have my old RAV4. So this is why we need to plasmatically convert our vehicles and start that whole ball rolling. And get things that are working without the nasty fuels that we've been fools for fuels, and that is, you can put that on a T-shirt and put my name under it. We're fools for fuels, and we've been fools for fuels for 100 years, and now it's time to wake up and try to shake off this addiction, this total addiction. Of course, when you're addicted to things, you can't see it from inside. You don't understand the addiction from inside. It's only after going cold turkey that you understand what the addiction is really about. And we're going to be shown that one way or another pretty quickly, probably. And we already are. We're destroying our planet so rapidly due to our fuelishness. We're fuelish humans, and we have to learn to become wary of fuels and become fools for plasma instead of fools for fuels. Anyway, I'm running out of breath after ranting so long, so maybe we should cut things off here. Or any other things that people wanted to show or tell before I got so carried away, so to speak. Stunned silence. Okay, well, maybe we should wrap it up for today. We've gone on for several hours of fun in the sun. Speaking of which, let's turn on the plasma balls for a finale here, maybe. Three in a row. Good luck. Got a fourth one actually, but there There we go.
Oh yeah, nice.
A little bit of plasma ball action, and let me just get the, I'll zero in on the camera a little bit there. Yeah, there we go. Maybe I can even turn off the other light. Can't get rid of the computer screen yet, or everything goes bye-bye.
Oh, fantastic.
That's about it. Oh, this sensor doesn't reach over far enough. I was going to give it a little blast, but actually I've got to... Let's finish off with... I'd like to see how this sensor works. It's been setting up, let's say, all day, so maybe it'll have some sort of interesting sound. It was a liquid, but now it's got a this little sensor here, which is a little ball of nano-coated materials, nano-coated copper, and Gans is in it as well. And let's just fire that up for a bit of a grand finale here, if it works. Oh, I'm gonna have to turn that down and put that over here and put that back up. And there, I didn't spotlight the video. I don't know if I was supposed to there. Okay, let's see if this here works. Of course, I can take my audio out and try to get this raised up to be able to hear it a bit. Back it down in order to tolerate these plasma balls. Probably have to tone it way down, actually, now that I think about it.
Oh, wow. Oh, that's neat.
Each one is a different frequency range. This sounds pretty cool. Yeah, it's great fun. I've got so many different sensors, it keeps me busy plugging them in and trying different settings and so on and so forth. Kind of drive you crazy. But let's see what the just before we go here, I'll plug in my my spooky, plug in spooky here.
Oh yeah.
We'll see what spooky hears, and I'm also going to I'm going to hook spooky up to the antenna. I'll plug that in at the same time. Let me get. Okay, it's all sort of mystical lighting here, but that's okay. You see the red one, I'll plug that in there, let's say. That may or may not work. I have to also work the little knob there. Okay, let's see if I get something out of this thing. You have to really crank it up. I'm not hearing anything right now.
Nicola, are you out there?
Sometimes the have to turn up the gain, I think. Okay. Sorry about that. That was rather loud. That's what thunder can sound. It's what lightning can sound like sometimes. Whoops, sorry about that. I got some loose connection happening that's causing a rather major disturbance there. Boy, I hope that didn't blow anybody's speaker system.
No, it wasn't that loud.
Oh, jeez, it's still jammed way up. For some reason, it just kicked in super strong. Now I have to back off all my settings, so I'm not sure what's going on there, actually. Oh, maybe it's these.
Have you got like an auto gain in it somewhere?
Like a what?
Like an auto gain.
Oh.
You know, stop.
Trying to do. I'll try my other import thing and see if it can work. I don't know. There's actually some sort of thing coming through here. Yeah, well, all kinds of different things. Of course, we got the plasma globes that'll interfere here as well, and so on. So it's pretty hard to get a clean.
Artifacts of the software and
Yeah, there's a lot of variables, so and it takes time to tune things in. I've had several tunings that are different now than they were earlier when I was playing with it. So
it's different every time. Yeah,
just the way it is. Yep. All right. Well, I think we'll wrap it up then for today. And let me
thank you.
phase back here from the big close-up zone. And let me wrap it up with one more little quick item here. This little device, what is the mystery tool? Any ideas? Quickly. Get your guess in. This is something Guy brought in. He finds these in the dollar store, in the thrift store rather. And I won't let you guess any longer because we have to get going here. But what it is a wire stripper. Before he told me what he was bringing, I thought, I don't want any more stuff here. I've been cleaning up for weeks. I don't want any more things, from the... And he pulled this out and I just went, oh, wow, is that ever cool? And what it is, you attach your drill to this part here, and that rotates, okay? That part here rotates. And it's got little wheels inside that... you can see the little, let me see if I can line this up. The wheels inside rotate, and that pulls the wire through. And it's got this little cutter wheel that you put down on the wire. I haven't tried it yet, but...
Length stripper. Cuts along the length.
Yeah, that's what it's made. It's an easy stripper. So, thought, wow, it's worth a try. It could be great for those... tedious wire stripping details. Of course, a lot of people have sort of automated ones and so on. But this would be great bolted down along with the wire coiling thing. So, many thanks to Guy. That was a good find. Brand new unit. Nice to see. It's just to let people know it's strips wire from 0.12 inches to 0.96 inches. It's called from Racketeers. It's called Racketeers, Tiers, and I guess that's how you could find it if you wanted to get one of these. Anyway, nice little find. Thanks, Guy. Good one. And that is going to wrap it up for today's session. Thank you, everybody. Thank you for presenting things. Big thanks to Lee Coates there with all the stuff that he was showing. It's really cool. And, we'll have more fun in the sun next week with the Keshe Plasma Reactor Group. So it's Rick Crammon for what's now Wednesday, November 2nd, Keshe Plasma Reactor Group. And... see you all next week, hopefully. Okay, so I'll end the live stream.